Hello and welcome to OPNEXT 2026. Thank you so much for joining us here in Midtown Manhattan at the iconic Times Center. We're going to start filling up this room and encourage people in the lobby, if you're hearing this, to come and join us. We're going to kick off some presentations. Charlie, we got a lot today. Can you tell us a little bit about what we have on this stage and the developer stage outside?
Yeah, this is the more general audience stage. This stage is being live streamed to our YouTube and Twitter. There is a Q&A, typically if there's time after each presenter. But the developer stage out there is going to be your more deep dives, dev stuff. So if you came here to listen about inscrutable technical stuff, that's where you need to be. With this, we'll have some panels up here. We'll have some general, I don't know, our programming is really good. I'm very proud of this. I have some PSAs, but I'll tag you back in.
Yeah, so thank you to our sponsors for making this possible: Anchorage Digital, Luxor, alloc, init, and then SWE outside. You can learn more about our sponsors by going and talking to them around the venue. We have the name badges, of course, and then thank you to a few of the other sponsors that made this show possible. You can see all of them outside on the welcome stage. In terms of the day flow, we're going to kick off here in a few moments. We have programming until 3:45. Doors close at 4:30. We have an after party where everyone is welcome to join at Pub Key down in West Village. That goes from 6 to 9. And then speakers, sponsors, VIPs also have an additional thank you dinner at the end of the day from 8 to 10. More details on that if you just want to talk to me. There's also stuff in the Telegram or in your email.
Okay, I'm gonna try not to miss anything, and if I do, I'll come back and reiterate it on the mic. There's a Wi-Fi code in the Telegram chat. The link is probably in your email to the Telegram if you're not already in there. Photo policy, we do allow photos, but I have two main photo and videographers running around. They have the real heavy-duty looking cameras, but obviously, be attentive to those around you who give off that body language that they don't want to be photographed. And then, that's all I can remember for my PSA.
Awesome. Okay, we're going to kick it off. We're going to welcome Anna Chekhovich of the HRF on stage to discuss Freedom Tech as we get going with OPNEXT programming. Thank you so much for joining us in New York this year. We look forward to an awesome conference day.
Yes, walk the trade. That's not how it works. Now, this is very much a he said, she said story. Riddled with drama.
Anchorage Digital is a platform for everything that an institution could need in order to interact in the digital asset ecosystem. If you are someone looking to buy assets, looking to hold assets, looking to stake, collateralize, trade derivatives, we provide the entire full suite, one-stop shop that any institutional investor might need in order to utilize digital assets. We have 1,000 clients on the platform and growing more every single day. And we are increasingly expanding the offering to support institutions looking to build businesses in the digital asset ecosystem. Folks that are looking to utilize the platform in order to integrate it into their bank, into their fintech, into their offering. That part of our platform is growing really nicely. And then additionally, we are getting big into the stablecoin business, looking at how to allow people to issue stablecoins, how to settle stablecoins, how to move stablecoins in the ecosystem.
Hello, everyone. My name is Anna Chekhovich. I'm a political activist in exile, and today here I represent the Human Rights Foundation. And probably some of you are wondering right now why a political activist is opening this conference. Because I understand that for many of you, Bitcoin is technology. It's an asset, it's a protocol, it's a startup ecosystem. But for millions of people around the globe, Bitcoin is something way more urgent. It's a survival tool. And I know about it because I came into Bitcoin through political repression. I'm originally from Russia, and for 9 years, I've been managing finances of Alexei Navalny's Anti-Corruption Foundation, the leading opposition organization in Russia. Alexei Navalny was the main threat to Putin's regime. That is why he was continuously prosecuted, imprisoned, and eventually murdered in a Russian prison by Putin's people. The Anti-Corruption Foundation was labeled an extremist and terrorist organization on the territory of Russia, and we were squeezed out of the country into exile. My name was added to the official list of extremists and terrorists in Russia. I joined Alexei Navalny's team in 2017 in Moscow during his presidential campaign when he decided to challenge the regime. He tried to run for president of Russia, and back then we had a huge network of activists. We had around 300 employees. We had offices all across the country. We had millions of supporters. We had tens of thousands of donors. And I was responsible for financial operations of the entire network. And that experience taught me something very important. When you fight against an oppressive government, money is no longer neutral. Money becomes a weapon, a tool of surveillance and control. And here is just one example from my work. I took this screenshot in January 2018 during my regular work day in Moscow. I came to my office, I opened my laptop, and I was supposed to send salaries to our employees on that day. And when I saw that picture, I immediately took this screenshot because I couldn't believe my eyes. I saw a negative balance on our account. The balance was so big, so I didn't even know what the number was. It was around -1 trillion rubles, which was approximately -$13 billion at the time. And as a financial manager, I almost had a heart attack. I was supposed to pay our employees, and we had this ridiculously negative balance. And at first, I thought it was a technical glitch, of course. But then I found out that they simply fabricated a criminal case against our foundation, and the bank was forced to arrest our bank account. And this was not just about our organization. This was a message sent through the banking system to everyone around us. It was a message to our donors. We can see you. We are going to punish you if you donate to Navalny team. It was a message to our contractors. We see you, don't work with them. And actually, it became really hard for us to find a contractor willing to work with us because no one wanted to receive money from the Anti-Corruption Foundation, because for everyone in Russia, it is clear that the banking system is fully transparent and fully controlled by the government, and people were simply scared to receive money from us. And it became a pattern over and over again. They arrested our bank accounts, and they pressured our contractors and punished our donors over and over again. So in 2016, the Anti-Corruption Foundation turned to Bitcoin. It became our financial lifeline, helping us receive donations, make payments, and every time when our bank accounts were under arrest, we had our plan B, we had our Bitcoin savings that we could use when we lost access to our fiat savings. And actually, eventually we started converting our fiat savings into Bitcoin to keep our money out of the government's reach. But in 2021, the Anti-Corruption Foundation was labeled an extremist organization, so we were forced to leave the country. We became completely illegal in Russia, and we relocated our foundation to Europe. And you might be thinking that life in exile made our work easier, but not from the financial perspective. Since Putin invaded Ukraine, now Russia is under financial sanctions, and the entire country is completely cut off from the global financial system. It's no longer possible physically to send money into Russia from abroad through the banking system. But we are still responsible to support political prisoners, their family members. We support political activists who keep fighting against the regime inside the country. And now it's only possible with Bitcoin. Also, as a nonprofit organization, we still rely on donations. We still receive donations from thousands of our Russian supporters. And if a Russian citizen donates to so-called terrorist organization, they will face up to 15 years of imprisonment. So we must be really careful when we choose the tools we work with. So right now we rely on Bitcoin in exile even more than before, even more than we did in Russia. And around a quarter of our budget circulates in Bitcoin. And unfortunately, our story is not unique. Today, around 72% of global population lives under some form of authoritarian rule. You can see on the map, red and orange countries are authoritarian and hybrid regimes, and blue countries are democratic states. So you're very lucky to be in a democratic country right now. And not only in Russia, dictators all around the globe use the same playbook. They weaponize money. When they cannot silence our voices, they simply shut down our bank accounts. They seize our donations, our savings, they punish the donors, they threaten contractors, and activists all around the globe, on the front lines and in exile, they're all facing the same challenges. Because when a dictatorship wants to shut down an opposition movement, they don't only arrest people, they cut the wires that let us function. So this is where Bitcoin enters the story. 4 years ago, I found this great nonprofit organization that is called the Human Rights Foundation, the American organization that empowers activists, freedom fighters, all kinds of dissidents with financial freedom technologies such as Bitcoin. We do it at HRF, we do it in many ways. We provide Bitcoin education, Bitcoin training, we provide Bitcoin grants, we support circular economies, we support community builders. Because at HRF we understand that opposition movements, they don't run on slogans alone. They run on logistics and they need real tools. And now at HRF, I lead Bitcoin education for at-risk communities. I pick the best Bitcoin tools, I pick the best privacy Bitcoin tools, and I teach activists how to use those tools in real life in their fight against dictators. And I learned something very important. The need for these tools, the need for this education is real. Since 2024, I've taught more than 1,200 students. And I see that it's a paradox, but it's true. Oppressive governments are unintentionally fueling Bitcoin adoption. The more they tighten control, the more activists, the more freedom fighters come to us to learn about Bitcoin technology. And in the period of 5 years, we provided around 300 Bitcoin grants for a total amount of $8.5 million of Bitcoin. We support not only activists and freedom fighters, we also support developers, those who build private Bitcoin tools for people like me. And I believe that if you build for Bitcoin, you are an activist yourself, whether you want it or not, but we are in the same boat. Because if you build Bitcoin infrastructure, if you build better self-custodial tools, if you build better peer-to-peer platforms, if you build open source tools, you don't just build products. You are actually expanding the space where people like me, freedom fighters, dissidents, can breathe, can operate safely, and we can operate without fear of surveillance. And this is why I believe this conference, this event, and this dialogue between us matters. So as you are spending this day today here talking about markets, prices, Bitcoin tools, I want to leave you with this message. Somewhere in the world, someone that you probably will never meet, one day that person will depend on your tool, on your project, on your product in the worst scenario, in the worst circumstances of their life. Right now, there is an activist or political prisoner's family member who is trying to survive, trying to operate under oppressive government that wants to isolate them financially. And you are, whether you know about it or not, but you are already helping them. So thank you so much for doing your work, and let's fight against global evil together. Thank you.
I don't like a company going bankrupt, but whenever something like this happens, you can go into Pacer, find the court filings, and then you have all this juicy open source information about who is involved in these things. Some of the names that have surfaced from this, there's some really weird stuff in here. Like, for instance, is the Chicago Blackhawks hockey team? This is real for $1.26 million.
At first blush, might be like, well, yeah, of course, just, check the boxes, dude. But if
Just
you
log
are
the trade, bro.
yeah, just log the trade. That's not how it works.
Now, this is very much a he said, she said story.
Riddled with drama.
Anchorage Digital is a platform for everything that an institution could need in order to interact in the digital asset ecosystem. If you are someone looking to buy assets, looking to hold assets, looking to stake, collateralize, trade derivatives, we provide the entire full suite, one-stop shop that any institutional investor might need in order to utilize digital assets. We have 1,000 clients on the platform and growing more every single day, and we are increasingly expanding the offering to support institutions looking to build businesses in the digital asset ecosystem. Folks that are looking to utilize the platform in order to integrate it into their bank, into their fintech, into their offering. That part of our platform is growing really nicely. And then additionally, we are getting big into the stablecoin business, looking at how to allow people to issue stablecoins, how to settle stablecoins, how to move stablecoins in the ecosystem.
Awesome. We're going to kick it off with our first talk, which has to be a recap of everything that's happened within Bitcoin over the last year or so. So we're going to bring on Mike Schmidt. He's the executive director of Brink on the state of Bitcoin Core. Give a warm round of applause for Mike.
I have the interesting position to be following dissidents and freedom fighters in Russia with 100 slides on Bitcoin Core. So hopefully we can handle this transition. The organizers came up with this title and I rolled with it. It gives me the thought of sort of this state of the union. Obviously, there's nobody that can speak on behalf of or for the Bitcoin Core developers. They're their own individual contributors. But one thing that I can do is help maybe speak about the work that some of these engineers are doing. And really, the state of Bitcoin Core in terms of its value to the ecosystem is up to you all to determine. That's not something that I have the authority to dictate here. So let's jump into it. I'm executive director at Brink, so I observe a lot of these engineers in their work every day. And even for the last 6 years beyond that, I've also been doing Bitcoin OpTech, observing the work that not only Lightning engineers are doing, but also these Bitcoin Core developers. And so hopefully I can convey some of that information for you all to make your value decision. There's a paradox in Bitcoin development and open source, in particular in Bitcoin Core, in that there are a lot of bits of transparency everywhere, but they're scattered. And so it's a bit opaque to someone trying to understand what's going on because, yeah, the code is right there, but I don't understand it. Or, yeah, there's this IRC meeting that I can see, but I don't understand it. So hopefully in this presentation, what we can do is take some of these pieces of transparency, these little class shards, if you will, and put them into something coherent that we can say that the Bitcoin Core project is delivering on these certain initiatives. So what is Bitcoin Core? This is from the bitcoincore.org website. Bitcoin Core is a software project that consists of its contributors. It implements node software as well as GUI, wallet, and some underlying cryptographic libraries. But anyone at the bottom here can contribute to Bitcoin Core. So who's contributing? This is a chart of authorship over time. The blue bar represents returning authors. And you can see there's sort of been this maybe 10-year period where we have a consistent 50 to 60 contributors that return to the project each year to contribute. Well, who are they? Here's the 50 to 60 that I pulled off of GitHub that are currently somewhat actively contributing. And so when we're saying, what is Bitcoin Core doing? Really what you're saying is, what are these individuals doing? And so what are they doing? Normally, crypto projects would have something like a roadmap articulating, what is coming next for Bitcoin, or what is coming next for the Bitcoin software. And so you see things like this in Ethereum, mapping out the next 5 or 10 years to a T. But we don't have that in Bitcoin. And Bitcoin Core, as a software project, also eschews some of these roadmap approaches. I highlighted, I thought it was funny that the Ethereum Foundation had a problem with the spelling of centralization up there on their roadmap. Okay, so we don't have a roadmap, but what we do have is observable work, these pieces of glass, these things that we can look at and say that you can tie it together and see what these folks are doing. We have observable work. One is the GitHub repository. You can look at changes proposed to Bitcoin Core at any time. That may be a little opaque to people, but maybe we can tie that in with some other things that we can see and get an idea of what these folks are doing. There's working groups. So if some of these volunteer contributors see that they're working on something similar, they might form a working group together and be able to collaborate on that sub-project or initiative together. These working groups would also then present at the Bitcoin Core weekly IRC meeting. There's essentially a public chat. Anybody can jump in, but weekly the core developers come in there and discuss things like these working groups, these initiatives that have clustered interest within the project. So looking at this sort of stuff might give us an indication of what they're working on. There's also tracking issues. Instead of seeing that big list of pull requests that we saw, and they're not tied together in any way, there's these tracking issues that sort of put those pull requests, draw a circle around them and say, these are actually related to this particular initiative. And then there's also notes from the in-person Bitcoin Core developer meetings. They get together twice a year, and some of them volunteer to write up notes about the different sessions that occurred so that we as the public can see what they're working on. There's also Bitcoin OpTech, weekly newsletter and podcast that covers developments in Lightning and also Bitcoin Core. So if we're looking to figure out what these folks are working on, these are a variety of resources we can use to deduce that. Okay, so what are the projects? There's ongoing work, which I'll get to, but there's also projects that these folks are working on. How can we start putting these glass pieces together? One interesting project is the mining interface that's come out recently. This is a way for mining software to more efficiently communicate with a Bitcoin Core node, specifically to enable something like Stratum v2 so that we can have more decentralized mining in the ecosystem. And one thing that I think is interesting about this set of initiatives is it actually relies on a project called multiprocess, interprocess communication, which is something that one of the Bitcoin Core developers was working on, toiling away at for over 10 years without any of that work seeing the light of day. But Stratum v2 in the mining interface was the impetus to sort of get that across the line and out to the public. And so you can see in a lot of these examples, it involves people working several years on a particular large initiative. Speaking of large initiatives, there's Bitcoin kernel. This is the idea that we can draw maybe some fencing around the code in Bitcoin Core that represents consensus or validation or the Bitcoin protocol and modularize that so that future developers can sort of see there be dragons internal to the project. And so that's good for modularization, but it's also good for other projects. There could be alternate node software that uses this consensus engine. There could be block explorers that build on top of this tooling or data science built on top of this as well. Silent payments. This is a way to have a more private Bitcoin address. It's actually reusable. It prevents address reuse. And it's also a user-friendly way to transact because you don't need to engage sender and recipient to get a new address every time you pay someone. And so there's been work all the way at the lowest level of cryptography, all the way up to the wallets to be able to support this sort of technology. There's Fiber. Actually, there's a discussion happening right now next door about Fiber, which is this idea of large miners are advantaged when blocks take extra time to propagate. And so any milliseconds that could be shaved off are advantageous to smaller miners in the fairness of mining more broadly. And so some Bitcoin Core developers are participating in rebooting this network that is essentially a high transmission for block relay to hopefully keep mining more fair into the future. And this is a dashboard that they've come up with. You can follow along with this sort of thing real time. In many cases, these not only the tools themselves, but also the reporting and the dashboard is also done by these engineers. There's Cluster Mempool. This is another multi-year project. I ripped someone's tweet thread and pulled this image out illustrating some of the benefits, better block templates, accurate fee estimation, and easier fee bumping. Maybe to illustrate why the mempool might be a little bit wonky these days in its current incarnation is that in some cases, the most profitable transaction for a miner to mine not only doesn't get mined in the next block, but actually gets evicted from the mempool. So that's maybe not a regular case, but I think it illustrates that there's some wonkiness in the current mempool design, and cluster mempool is designed to fix that, among other things, including helping to enable package relay, which is this idea of being able to broadcast more than one transaction at the same time, which is quite critical for things like Lightning, whose security assurances are being able to get a transaction into a block in a timely manner. And while there's still work being done on this, these are some feedback from Lightning node maintainers about the value of not just this work, but some of the mempool and policy work that went in to enable some of this, a lot of which was done by Gloria. There's also work on a new GUI. Maybe we get something that runs on mobile. Maybe we get something with a little bit better usability. We'll see. This is an in-flight project, and there's engineers working on it right now. Private broadcast will be something that's coming in Bitcoin Core version 31. The idea here is that in order to transmit your transaction to the broader network, you relay it through your peers. And in some cases, those peers can be made up of surveillance nodes trying to decide if that transaction is actually from your node. Are you the owner of that Bitcoin or not? And so they can actually identify you, which is obviously bad for privacy. So there's this initiative that Vasil worked on for 2 years, including 1,000+ review comments from a couple dozen reviewers in order to get this so that you can actually broadcast your transaction more privately using an ephemeral Tor connection. ASMap is an interesting project as well. The idea is that you want your node to be connected to honest peers wherever possible. So you want to select a diverse set of nodes that you peer with. But it's possible that some of your peers, or maybe all of your peers, are actually owned by the same entity, and they can execute what's known as an eclipse attack on you if that's the case. So we had one engineer that worked on essentially mapping out the entire internet, who owns which IP addresses, and then when you're making a node connection outbound, you can figure out if that is somebody who is, maybe all those IP addresses are owned by the same entity. And so this required him going to conferences about networking, proposing this idea to be able to reproducibly map the entire internet into a file that could then be used for such mapping, to which the networking experts said that is impossible, but one of the Bitcoin Core engineers did it anyways, and we now have ASMAP rolling out with Bitcoin Core version 31 as well. So in the spirit of this State of the Union, I would guess my fellow Bitcoiners, do we want our engineers defying the experts and mapping out the entire internet so that we can have a well-connected node that doesn't get eclipse attacked? I think the answer to that is yes. We do want people working on these sorts of things. There's also quality of life for node runners, IBD speedups. That can be in the form of incremental improvements, which you see over here, IBD times being knocked down over time to basically half their time from previous versions. There's more, there's bigger projects around this as well, like Assume UTXO in the same vein. You can get your node up and running sooner, and meanwhile do the background validation while having a node that's operational. And more recently, there's some innovations in proof of concept around something called SwiftSync, which is a different approach to full initial block download and getting your node up and running that is 5 times faster than vanilla initial block download. A few Bitcoin Core developers helped out with an independent security audit last year. We engaged Quarks Lab, which is a French firm, to do security audit in conjunction with the OSTIF. And while they looked at sensitive parts of the code base and the tool chain and testing approaches and weren't able to find a security vulnerability themselves, I think that it served as a great signpost for the project that they have the right approach to security, they have the right approach to the build system and testing. I already have 100 slides, so I started to have to cluster some of these onto their own. There's projects like refactoring, modernizing the build system, benchmarking so that changes can be known if they're causing performance bottlenecks, research into Erlay so you can have more connections through your node with the same bandwidth, fee estimation improvements to the testing networks, improvements to the wallet, including Music 2 coming out soon, Send Template, which is investigating with this diverse mempool ecosystem that we have now, how best can we mitigate that, translation so that the software can be run in any language, research into batch validation, indexes, documentation, REST, RPCs, etc. But there's also cross-cutting concerns, things that apply regardless of the individual project, right? So there's things like code review. This chart shows the number of comments on merged PRs, and you can see back in 2011, you'd be lucky to maybe get 2 comments on your pull request before it gets merged, whereas now we're approaching 20 comments per pull request, which sort of mirrors this statistic, which is the time it takes a pull request to get merged based on its size, and you can see even a small pull request is now taking nearly 35 days, whereas larger pull requests might take a few months. And so you can see in both of these charts that there is an up and to the right movement, which I think reflects the conservative development culture. There's also testing, lots of kinds of testing. There's manual testing, where an engineer pokes at the code themselves. There's unit testing, where you might contrive a few different test cases and see if they pass. There's functional testing, where you actually maybe spin up a node or a few nodes and mine blocks and broadcast transactions and ensure that everything is working end to end. There's fuzz testing, where instead of putting a few contrived tests towards the code, what you can actually do is what I like to call like mining for bugs, which is you put a bunch of quasi-random variables into the functions and see if you can find abnormalities or crashes or edge cases. And then you want to do that fuzzing continuously, which is what a project called Fuzzer does. It's continuous fuzzing, so we have the software continuously being tested all day, every day. And then there's things like Fuzzomodo. Oftentimes, in order to implement a test, you actually need to change the Bitcoin Core code itself, which, as we've seen, can take weeks or months sometimes. And so Fuzzomodo end around that by actually testing, using the actual end software, how an end user would do it, sending peer-to-peer messages to the node, seeing what happens, and testing that way. But that's not it. We got more testing. Bitcoin Fuzz, this is differential fuzzing. So this is saying, how does Bitcoin Core handle this input to the consensus engine versus how BTCD or the Bitcoin or NOTs might handle the same input, and doing that hundreds or millions of times and seeing if there's abnormalities that can surface, which might be indicative of potentially a consensus bug in one of the implementations if there's different output. There's sanitizers, which instrument the code for checking for things like memory errors. And then there's mutation testing, which is actually testing the tests. So modifying the actual source code, seeing if the test can actually catch that. And so I guess this is another one of those things where it feels, my fellow Bitcoiners, like this is the kind of work we would want our core developers doing. If it sounds like a lot of testing, that's because it is. I took a look myself at the code essentially between version 29 and 30, categorized those pull requests, and tests far outweigh the other types of pull requests to the repository, followed quickly by the build system and docs. Speaking of the build system, we need to take this code and we need to have it something trustworthy, runnable on our machine. We need to go from code to executable. First step there is the CI, or continuous integration. This is a system that will automatically run many of the tests that I outlined in the previous slides, so that when someone submits a proposed change to Bitcoin Core, that these tests are automatically run and there's a quicker feedback there. We also need to actually build the binary. There's this cool tool called Geeks, which is 300 bytes of small functions that essentially can iteratively build itself larger into a compiler and then eventually Bitcoin Core, so that you, when you build on your machine, know that you have byte for byte matching to what has been published, and that nothing has been intervened in the meantime. And then there's folks who attest to those byte for byte comparisons so that you can have trust in the software and not necessarily trust in the engineer that hit the build script to build the software at one time. But there's code other than just Bitcoin Core's code that runs Bitcoin Core. There's libraries, which are called dependencies, and there's attack surface there, right? We've seen things like attempted backdoors in open source projects so that folks can get access to other people's machines or maybe get access to their Bitcoin node in an inappropriate way. There's a series of initiatives in Bitcoin Core to eliminate these sorts of dependencies and this risks. One such was libsec P256K1, which replaced an old dependency many years ago. And as you can see here, 10 years on, the red bars are performance. So not only did these red bars are OpenSSL performance, and the green bars are the Bitcoin-specific libsec P library doing similar cryptographic operations. And you can see, so not only was a dependency, a potentially attack surface eliminated by removing that dependency, but also it's actually more performant. And so there's these sorts of removals are underway now. But despite everyone's best efforts, there are still vulnerabilities that occur. Oftentimes, these vulnerabilities are actually found and fixed by Bitcoin Core engineers themselves. But there is a security list for people to submit these sorts of issues, which are triaged by seasoned Bitcoin developers, which are then put into fixes, backported to previous versions, and then responsibly disclosed on the Bitcoin Core website. But not only that, some engineers are taking a look and categorizing these sorts of vulnerabilities by their impact or which components are affected so that we can prevent these sorts of bugs from happening in the future. There's also a guy, which is now becoming a group, that focuses on monitoring. B10C has this mainnet observer, among other properties, that are real-time observing activity on the Bitcoin network, categorizing it into certain charts or graphs, and trying to surface things that might be awry in the network before other folks figure it out. He was the one to sort of come up with this ant pool and friends, the fact that a few of the mining pools were working together, which wasn't publicly disclosed at that time. He's also now actually starting his own forum to talk about this data science. He's calling this the Bitcoin Network Operations Collective, where other people can contribute what they've found on the network and hopefully proactively potentially identify issues on the network. There's work on the protocol as well. Coming up next, we're going to talk about BIP54, which is a proposed protocol change to fix 4 vulnerabilities in the Bitcoin protocol that have existed since Satoshi's initial version. There's, I think, 4 discussions on quantum at this event. And there's a lot of discussions and proposals on quantum going on right now. It's an active area of research. There's also work into something called cross-input signature aggregation that could potentially decrease combined signatures, which results in less fees, but also potentially more privacy. And then there's work on scripting things like op template hash that Bitcoin Core developers are working on as well. Okay, so who is funding these engineers? If you asked 6 or 7 years ago, it would be these 3 organizations funding the entirety of Bitcoin Core development. Now we have over a dozen, which is good for Bitcoin from a decentralization perspective in many ways. Of course, there's more organizations, there's more jurisdictions. Some of these organizations have different focus areas like privacy versus security. Some work on things other than Bitcoin Core. Some have offices, some employ people, some give grants, and so I think this makes for a robust funding ecosystem. 1A1Z did a study in the last year or so and concluded that these engineers, money spent on these engineers is something like $9 million per year, which I guess we're in New York, you could do, OpEx kind of stuff. This comes out to be 6/10,000ths of a percent of this $2.5 trillion asset. Okay, so that's the work that these engineers are doing, but we all need to evaluate how we think they're doing. One group that we could ask how Bitcoin Core is doing, who's quite antagonistic to Bitcoin Core, is Bitcoin Core. These are the biggest critics of the project themselves. They might say things like, well, what's the architectural future? Why do we have the GUI and the wallet and the node all together? Should we be separating these things? Is there a risk of keeping them together? There's competing priorities. I mentioned initial block download and the series of improvements for that. Well, in some cases, that required touching something potentially sensitive. So now you're trading off performance of IBD and potentially risking security. So there's these competing priorities. There's also stalled projects. Often projects make some progress. Maybe they even get launched, but there was additional things that were originally promised as part of that project. Or maybe it was deployed, but it wasn't maintained. And so this is a frustration of these engineers as well. I might add in a few of my own. Attracting developers. We want, this is a growing $1 trillion asset. We need a pipeline of quality engineers. We need to ensure that they're working on the most important and impactful work. And then we need to be able to have the funding to retain them into the future. So we could ask the Bitcoin Core developers, but we could also ask social media how the Bitcoin Core developers are doing. And I tend to see these criticisms in, yeah, Mike, all that stuff you said is good. Sure, we want security. Sure, we want tests of the test. We want 9 different kinds of testing. But also, we want the Bitcoin Core developers to be worried about spam and treating it as a denial of service vector similar to other denial service vectors. Or, yeah, Mike, that's all great. Sure, code review is getting more conservative, but also quantum should move faster. Obviously, we'll have quantum discussions today. Yeah, Mike, that's great. You guys find all those bugs and fix all those bugs, but also we want more scripting capabilities. And I think with a lot of this, I would advocate in closing to you all that if we're going to evaluate the Bitcoin Core developers in the Bitcoin Core software project, that we should evaluate the yes, all that, in addition to quantum or spam or whatever else people are bringing up. And so that's what I'll leave you with. If you're curious about some of the data points that I've used here, this is a slide that links to a bunch of resources that you can use to dig into these charts and open information yourself. Thank you very much.
Anchorage Digital is a platform for everything that an institution could need in order to interact in the digital asset ecosystem. If you are someone looking to buy assets, looking to hold assets, looking to stake, collateralize, trade derivatives, we provide the entire full suite, one-stop shop that any institutional investor might need in order to utilize digital assets. We have 1,000 clients on the platform and growing more every single day, and we are increasingly expanding the offering to support institutions looking to build businesses in the digital asset ecosystem. Folks that are looking to utilize the platform in order to integrate it into their bank, into their fintech, into their offering. That part of our platform is growing really nicely. And then additionally, we are getting big into the stablecoin business, looking at how to allow people to issue stablecoins, how to settle stablecoins, how to move stablecoins in the ecosystem.
Okay, we're going to keep it rolling. Oh, we got Charlie and Colin up there for a second. That's our Blockspace live show. If you're on Spotify or Apple, go check that one out. We're not just an events business, we're a podcast business too. So check that out if you want more Bitcoin content. We have Antoine on deck next to give us the state of the Great Consensus Cleanup. Antoine was at OPNEXT last year, so it's his second time speaking with us. Give Antoine a warm welcome to stage.
Thank you. All right. Can I have my slides? All right, so I can start without the first slide. It's just the title anyways. So my name is Antoine Poinsot. I work at Chaincode Labs on Bitcoin Core and the Bitcoin Protocol. Today, I'm going to talk about the next steps for BIP54, the consensus cleanup proposal. I'll start by going through each item from the proposal, each of the 4 items, but I won't go into too much details. If you want more details, you can watch my talk at OPNEXT from last year, or you can also visit Mike Schmidt's website, BIP54.org, that contains a lot of information about BIP54. All right, I'll know my slides by heart. So the first item of the proposal that I'm going to talk about is time warp. Time warp is an implementation bug in the Bitcoin proof of work. This implementation bug enables a majority miner to artificially increase the block rate, which is they can massively speed up the block rate. In the worst case, can you go down 2 slides, please? Yes, thank you. In the worst case, they can speed up the block rate up to 6 blocks per second. At this point, all denial of service protections baked into full node validation go out the window. At this point, full nodes are not in control of resource usage anymore. To give a figure, with 6 blocks per second, you could add something like 500 gigabytes to the UTXO set in a single day. But that's considering the worst case is really considering an attacker that is externally incentivized to attack Bitcoin. They wouldn't gain much internally to the system. Of course, we shouldn't discard these types of attacks. We should consider external attackers for a system as important as Bitcoin. But I think what's more concerning is that there is also incentives for potential internal actors to collude and only increase the block rate by a small amount. For instance, twice the block rate, or increase the block rate by a factor 10, such as you have, on average, a block every 10 minutes. what this would achieve is that short-sighted miners would get more block subsidy, because there's now a block every minute, by stealing it from future miners. And I guess it could also content some short-sighted users that now have more available block space, which, all other things equal, would mean lower fees to show whatever on-chain data that you want to put on the blockchain. Of course, all this would come at the expense of the long-term health of the system. The fix for the mitigation for this bug is straightforward. The bug in the proof of work is an off-bound that makes it so difficulty adjustments, every 2016 blocks, do not overlap. So there is one small additional rule on blocks, the timestamp of blocks at the boundaries of the difficulty adjustments. Can you go to the next slide? Thank you. So the next one I'm going to be talking about are blocks that take a long time to validate. Can you go to the next one? Thank you. Today, on Bitcoin, it's possible to have blocks that take like up to half an hour on a mid-range server to validate, and up to over a handful of hours on a Raspberry Pi. And Raspberry Pi are very common by single individuals that buy these node-in-a-box solutions. Those could be stalled for 5 hours or more with a single block. So of course, slow blocks also are an issue in the worst case for an externally motivated attacker. For instance, an attacker could try to prepare an attack that is going to send a dozen slow blocks, such as to stall the Bitcoin network for a while and short the Bitcoin price before. But it also creates perverse incentive within the systems, as it becomes one other tool in the belt of the optimizing miner, who can now try to leverage not the worst case of the long block validation times, but smaller ones that are also a lot cheaper to create in order to stall their competition for 5 seconds, 10 seconds, and always have a head start of a dozen seconds. The fix for this is to limit the number of legacy signature operation per transaction. This is because in transaction validation, you have some operations that are quadratic in the size of the input. And limiting the number of signature operation is a proxy that is more flexible than just limiting the size of the legacy transaction, such as someone that is trying to use a larger legacy transaction, but is not trying to make a pathological transaction that is going to be hard to validate, can still continue to do so. And someone that is trying to attack with maybe a slightly shorter transaction is still prevented from doing so. So this fix is pinpointing exactly the behavior that is harmful and leaving any other behavior still valid. Can we go to the next one? So the next one is about malleability in the Bitcoin Merkle tree that allows to create fake proofs of inclusion in a block. Nice. Can you go to the next one, please? This is an issue that could be used to trick SPV verifiers into accepting a transaction such as if it was part of the most proof-of-work chain, whereas it is not. So it can be exploited by an attacker with some amount of brute force. It doesn't come for free, but with this, they could trick, for instance, some wallets that are using SPV verification, but nowadays, it's more common to see SPV verification used by bridges to side systems. You could fake inclusion of a transaction that bridge into the system on Bitcoin, whereas you actually never paid this money on the Bitcoin network. There is a mitigation that exists today, but the mitigation is maybe cumbersome to roll out in some environments. And more importantly, you need to know that you need this mitigation in the first place. You need to know about this obscure bug in something as fundamental as the Merkle tree in Bitcoin blocks. The fix in BIP54 is to just make this vulnerability go away entirely by making 64-byte transactions invalid, such as it's not a better mitigation for the systems, it's just making it so it's not possible to attack anymore in the first place, and you do not have to roll out a mitigation. 64-byte transactions are already insecure anyways. They can, if you want to use a 64-byte transaction, first of all, it's not going to be included by default by miners running Bitcoin Core, and it's not going to be relayed on the network. It has not been for, I think, over 7 years now, but it's also so small that any output of a 64-byte transaction will have to either burn the coins or let them to be taken by anybody. They're already insecure in the first place. The next item in the proposal is not fixing a vulnerability itself, but cleaning up a fix for a past vulnerability in Bitcoin. Can you go to the next slide? Early on in Bitcoin, it was possible to have 2 separate transactions that have the exact same unique ID. If that sounds bad, that was bad. And it was reported to Bitcoin Core, which at the time was called just Bitcoin, by Russell O'Connor. And when reported, Bitcoin developers came up with a stopgap solution that is BIP30. After BIP30 was rolled out on the network, they cleaned it up with BIP34, such as the stopgap solution was not necessary anymore because BIP30 unnecessarily increases the work that you need to do when validating a block, and also prevents more modern alternative designs of full nodes. For instance, the U3XOR full node would not be able to perform BIP30 validation. And unfortunately, with BIP34, BIP34 has an expiration date. At some point, we will have to resume the stopgap solution. So BIP54 includes an item that makes it so we will never have to resume the stopgap solution ever. Unfortunately, and this is the only item in the proposal that is so, it requires action from miners. Normally, any reasonable soft fork proposal only invalidates what is not actively being used by the network. Unfortunately, in order to fix this bug, it is necessary to get miners to make some small adjustments in their Coinbase transactions, which means that we need miners to update their software. It is not, with past soft forks, you could upgrade your Bitcoin Core software and it would make you compatible with the soft fork. Even if you didn't upgrade to a version of Bitcoin Core that had the soft fork, as long as you use the default, you would not create an invalid block. Currently, some miners, those that have not yet upgraded, create blocks that would be invalid to according to BIP54. Thankfully, the adjustment is very simple to make. It's just about changing the lock time in the Coinbase transaction. Unfortunately, miners are difficult to reach for some of them. So BIP54, so before talking about what's next, BIP54 is fixing vulnerabilities that have been known for a long time. One of them since 2010, another one since 2013, another one since 2017. In January of 2019, then Bitcoin Core developer Matt Corallo proposed the great consensus cleanup, a bundle proposal to fix all those long-standing bugs in the Bitcoin protocol that just created unnecessary risk to the network. The progress on the proposal then stalled as Matt moved on to work on the Lightning Network. And at the end of 2023, I started investigating this stalled proposal. Are the bugs that is proposed fixing that bad? are the mitigations that it proposes the best one we can come up with? If we are going to go through the whole process of doing a soft fork to fix long-standing bugs in the protocol, do we have any other items that we would like to include in the proposal? In March of 2024, I published this research, and then throughout 2024, I had a lot of feedback from various developers and researchers on Bitcoin about, and discussions and pushbacks and new ideas for variants of some of the attacks. For instance, the time warp attack has a variant that was found during the review of this thread. Ultimately, as we converged on a set of mitigations, I co-authored in March of 2025 BIP54 that contained the mitigation for each of these items. Throughout 2025, we, how would you say it, refined each of the, like the specification of BIP54, made some final adjustments to some of the mitigations, and started working on the implementation. I opened a pull request to Bitcoin Inquisition in December 2025, I think, or maybe even before. And Bitcoin Inquisition is a test bed for consensus changes to Bitcoin. This pull request was eventually merged in Bitcoin Inquisition, and BIP54 was activated on the Signet network through Bitcoin Inquisition in March of 2026. Then we also did a demo last week on the Signet network for slow blocks that you might have heard about. But also, I hope that this description of the timeline highlights what is going to be on the next slide, which is, from the outside, soft fork proposals are often perceived as being through one champion. And although I revived with the thread of the GCC revival the efforts around this proposal, can you go to the next slide, please? This is now not really only my proposal. The BIP54, as it came about, has had direct contributions from every single individual in the slides, which, whether it is in terms of ideas, code, review, data, pushbacks, maybe. So this is not a one-man project. It can't be as a soft fork, and this is now really a community effort, and I'm just one of the person talking about BIP54. So what's next for BIP54? One item that is next is going to be on the next slide. I know, I think I've got a joke slide first. Can you? Yes. What's up next? So the first thing that is going to be next, that is on the next slide, is we need to continue the community engagement. Let's face it, BIP54 is boring. It's not including more features. It's just boring long-term risk mitigations. It's not fixing sensational security vulnerabilities. It's just patching vulnerabilities that just are unnecessary risk in the long term to the Bitcoin network. And because there is no shiny features, it's sometimes harder to get non-technical people in the community or companies to engage, because you won't be able to build the next great product with BIP54, or you won't be able to unlock this great UX for your layer 2 protocol with BIP54. Nonetheless, I think, and a lot of other things, that it's important to do this work. So it's important to keep raising awareness, even if it's less shiny. Can you go to the next step? Obviously, one big blocker is to get miners to make the small adjustment in their Coinbase transaction. So it's important, if there is miners in the room, talk to me, talk to another Bitcoin developers about what's necessary to be compatible. Thankfully, we already had some take-up from miners in the past couple months. We had one obscure mining pool that's called White Pool that has a very low percentage of the hash rate on the network. I just emailed them, and they made the adjustment. There are others like Mara Pool, pioneers of Bitcoin innovation. They were very receptive and made the adjustments directly. So we have about 5% of the hash rates now that is compatible. And this is, can you go to the next slide, very, very importantly, about compatibility. This is not about asking miners to activate the soft fork. This is just making it so it's as any other soft fork, miners could make valid blocks, whether Bitcoin users choose to validate the soft fork or whether they choose not so. Because currently, those miners are a blocker to choose one of the two paths available to the Bitcoin users. So this is not about signaling activation. This is just about making it, their blocks compatible regardless of activation. And then, I guess, of course, at this point, I think that, as appears on the next slide, it would be time to propose an implementation to Bitcoin Core. I think such an implementation should not contain any activation parameters. I think we should separate the discussion about whether the Bitcoin Core project thinks this is a project worth moving forward from the discussion of how should this soft fork be activated. I think it should, however, contain activation parameters for testnet, because so far we have it activated on Signet, but Signet does not have miners. So it will be interesting to have it on testnet for a while as well. So that's probably going to be the next big step in parallel with talking to miners, such as just make the small tweak in the Coinbase transaction, and which I anticipate this will help as well. This is it. I left some time to take some questions if you have any. If you want more information, again, this website is a goldmine of information about BIP54. That's a QR code to the website. The name is bip54.org. That's simple. Yeah, so Will has a mic, so the live stream can hear your questions as well.
Howdy. Thank you very much. That was an awesome talk. You mentioned in BIP54 that it helped enable U-Tree-XOs, maybe because their transactions are bigger. Does that imply there's motivation to make U-Tree-XO happen in the future?
I think there may be some users that opt into using U-Tree-XO. U-Tree-XO is just a design of a full node that makes different trade-off from regular Bitcoin Core. Uses more bandwidth, but it uses less storage for the UTXO set. Some users may opt into that. What BIP54 allows is to not corner users into only using a Bitcoin Core model or another model of validation, because the current rules of the Bitcoin protocols make it so U-Tree-XO would not be a full node anymore in, I think, 10 years from now, because we will have to resume to the stopgap solution, which cannot be implemented in the U-Tree-XO model. So this is not about enabling U-Tree-XO, it's about avoiding making it incompatible for no reason.
Hi, miner here. What do miners need to do to signal compatibility with this transaction ID, duplicate transaction ID thing?
Yes, so to produce compatible blocks, miners need to set the block height in their Coinbase transactions lock time. So technically, it's the block height -1. Because currently, miners that are not compatible set just the lock time, which is 4 bytes, to a dummy value, which is 0000. And in order to make the Coinbase transaction unique, which is because all coins originate from the Coinbase transactions, is going to make all transactions unique. We need miners to just set the lock time in the Coinbase transaction. That's all of it. Usually, from the open source mining pool implementation that I've seen, it's literally one line in the Coinbase generation function that currently just hard-coded to 40 bytes. And the function already has access to the block height because of the BIP34 requirements that already exist. Yes, can you say it in the mic? He did it before. So.
I just wanted to point out, if you're an individual miner, that's only applicable to mining pools or solo miners. So, yeah.
Yes, so that's mining pools, or if you mine a solo mine. and generate your own Coinbase transactions.
I'll just add to that. You can also use Stratum v2, and it will just work TM, because we've kind of designed it to already set those fields.
So the operator of F2 pool commented on X that he wasn't comfortable with there being 4 different changes rolled up into one soft fork proposal. Do you think that these should be split up so that the community can weigh them individually?
Yes. So the operator F2 pool said this among saying that slow blocks are not an issue since we have libsecp, and saying that time warp is not an issue because miner would never do this to you. But I think the bundle is a reasonable objection that needs to be addressed. The BIP54 is about bundling related changes that are all long-standing issues in the Bitcoin protocol. Doing a soft fork is and should be hard to do. So it's unrealistic that we would be doing a soft fork for every item separately. And it's also not as if we were bundling different features, such as if we were bundling, I don't know, BIP54 with opcat, or BIP54 with op template hash or CTV. These would be like obviously unrelated. All the items from BIP54 are related in that there are long-standing vulnerabilities in the protocol that we could easily fix with a soft fork. Yeah, for the live stream.
And to your question, I think the individual who made that statement was sort of making an analogy to politics and pork barreling, where you take a popular, uncontroversial legislation and you stuff something that is controversial below it to kind of get it through. And here we have 4 very uncontroversial changes that are arguably all related. And so I think the analogy there is broken, and it's unfair, I would say.
All right.
Awesome. Put your hands together for Antoine. We're going to go to a short break for 2 to 3 minutes, and then we'll have a final speaker before we go to an actual break for 15 minutes. So stay tuned, stay in your seat.
Who in the world is mining Bitcoin in Australia right now? I mean,
I don't like a company going bankrupt, but whenever something like this happens, you can go into Pacer, find the court filings, and then you have all of this juicy open source information about who is involved in these things. Some of the names that have surfaced from this, there's some really weird stuff in here. Like, for instance, is the Chicago Blackhawks hockey team? This is real for 1.26 million.
at first blush, might be like, well, yeah, of course, just, you know, check the boxes, dude. But if
just
you
log
are,
the trade, bro.
Yeah, just log the trade. That's not how it works.
Now, this is very much a he said, she said story.
Riddled with drama.
Anchorage Digital is a platform for everything that an institution could need in order to interact in the digital asset ecosystem. If you are someone looking to buy assets, looking to hold assets, looking to stake, collateralize, trade derivatives, we provide the entire full suite, one-stop shop that any institutional investor might need in order to utilize digital assets. We have 1,000 clients on the platform and growing more every single day, and we are increasingly expanding the offering to support institutions looking to build businesses in the digital asset ecosystem, folks that are looking to utilize the platform in order to integrate it into their bank, into their fintech, into their offering. That part of our platform is growing really nicely, and then additionally, we are getting big into the stablecoin business, looking at how to allow people to issue stablecoins, how to settle stablecoins, how to move stablecoins in the ecosystem.
Okay, we're keeping it rolling here at OPNEXT 2026. Thank you so much to our sponsors for making today possible. We have a shorter presentation right now with Misha Komarov of alloc.
Who in the world is mining Bitcoin in Australia right now?
Charlie just coming in from the top ropes with some stuff from our podcast. Love that. So we have Misha Komarov of alloc, who's going to be joining us on stage to talk about expanding and making Bitcoin functionality easier on L1 through cryptography. Let's welcome Misha to stage.
Yo, they didn't give me the mic. All right, it's fine. Okay. All right. Yay. Let's start, I guess. Covenant talk is back. So what's going on? For the last couple of years, we've seen a lot of attempts to, well, hijack Bitcoin, to change it, to whatever, approve something which, or like to push through something which community doesn't approve. Well, Bitcoin is already complicated. Don't overcomplicate it. Don't overcomplicate the protocol. And that's kind of my point here. Don't risk the security. And that's what we're going to be talking about in here. That's what pipes are all about. It's all about introducing governance and missing opcodes on Bitcoin without attempts to break it, without attempts to screw it up, without attempts to just don't touch it. It's good. So what's the problem? Like, and what limits, actually, people from breaking Bitcoin? Governance paralysis. Is it bad? Is it good? I mean, we have it, okay? Like, Bitcoin is ossified. The governance is paralyzed. Actually, I think it's good, you know? Well, sorry. So, but we're getting no upgrades, and that's fine, you know? That's fine if you just want to use it as an asset and like things for payment. But sometimes you want to do it for like more advanced payments, like private payments, or you want to collateralize it, or you want to do something else. You cannot do that without a third party if it's not a part of Bitcoin. So can we bypass the governance paralysis for the sake of getting these things done? Yeah, like apparently we can. Over the last 2 years, we have found out that it is like a concept which we've introduced called Bitcoin pipes effectively gets you that. What are we doing there? We are offloading all the compute you need from Bitcoin itself, from the protocol itself, to off-chain conditions. We enforce them cryptographically outside of Bitcoin. And yes, it's witness encryption, but you know, it takes some time, it takes some effort, but it's doable. This way, you bypass the necessity to change the consensus rules if you need something else from Bitcoin besides what it has right now. Like the opcat conversation, forget it. The opctv conversation, forget it. The opcsfs conversation, forget it. That's the thing. Okay, well, actually, we'll talk about nuances. Come to the dev stage for my talk. We'll talk about nuances about stuff. So let's not, you know, kind of. But in general, that's the message. And yeah, I mean, that's what I said. Like, you probably, or you might have not heard about like maybe a year and a half ago about Bitcoin pipes in general. We've presented that as a concept. We've spent last year and a half, I guess, trying to, well, actually make that work, actually deploy that somehow to be able to implement that. That's what we did, I guess. At least we've published the V2 recently. We've published the underlying witness encryption scheme. We are doing, okay, let's talk about that. We are doing a lot of security analysis. We are doing open challenges. We are making sure that cryptography doesn't break. And this gets us, well, once it's all done, once it's all said and done, it gets us, well, we can say goodbye to multisigs, I guess, to multisig bridges. We can say goodbye to, well, interactivity for the sake of, well, if you need to collateralize something or you want to do like private transfers or something else, right? So that's kind of interesting. And the fun fact is apparently we can do that within 10-minute block time. So, I mean, apparently it's possible to do that within block time, within the block time. So that's pretty interesting. What is witness encryption in general? What am I talking about in here? So the thing is all about key management. It's a very classic thing, very classic stuff, what you do around Bitcoin. If you want to have, well, some kind of complicated behavior for the transaction, you either pre-sign, either you do some keys, either some tricks with the keys, DLCs, anything else. So that's just one more key trick. It's just a pretty sophisticated key trick. It allows you to decrypt the key based on some programmable condition, like NP statement. That's kind of what witness encryption is all about. And well, yes, it's been a mythical creature for quite a while, I would say, like for maybe at least 10 years. But I think because of how some other L1s in crypto industry died for this research, I mean, they literally poured all of their budget into this kind of research, and now Bitcoin uses it. It's kind of fun. I'm not kidding you. Because of that, well, we have it on Bitcoin. Kind of interesting. Yeah, so Bitcoin Pipes V1, as I said, published it some time ago. It was a concept, made some noise, you know, got back to development, got back to the drawing board. Good. Quite a lot of conditional decryption-based approaches also kind of got incentivized to pop up because of this, like the garbled circuit stuff for BitVM. All of that. I mean, it's actually pretty good that people started thinking about the conditional decryption-based techniques. It's the way. I mean, I think it's the way. So the V2, I mean, if you want to take a look, take a look. Kind of, yeah. There are upsides, there are downsides of this. It's more practical, implementable, something which, you know, can be thinking can actually work. Though, right now the ciphertext is a little bit large. So per each decryption, like each covenant costs about, I don't know, maybe like $100 per decryption. We will reduce that to, well, about maybe 50 gigs per ciphertext, which will get the cost down, well, maybe 10 to $20 per decryption. So like 10 to $20 per covenant is kind of comparable actually with Bitcoin fees at this point, kind of. So the general workflow of like conditional decryption stuff, right? Like all of the conditional decryption, all of these sophisticated transaction, conditional transaction behavior, like conditional, whatever, like key behavior, like key tricks. It's all the same. I mean, you lock the funds, you prove some term, you prove something, you prove some compute, like opcat, off-chain opcat, or like off-chain CTV. Okay, well, with nuances, but whatever. Off-chain CSFS. Well, this is less nuanced. This is pretty straightforward, actually, because it's a binary covenant. Come to the dev talk. I'll talk about this as well. And then whatever you get as a result of this decryption, you submit to Bitcoin. You can do it all yourself. You don't need a third party. It's all just crypto. It's all just cryptography. It's cryptography. So kind of the thing. So covenants, right? Like, you know, I was talking about covenants, et cetera, just in case reminder, a little bit of reminder for those who maybe have forgotten. Covenants is the way to define, if the transaction is about to be spent or should be spent based on some conditions or not. there are different ways to induce covenants. You can do that off-chain. You can do that inside Bitcoin. All the attempts to make that happen inside Bitcoin, I mean, kind of failed at this point. I mean, again, because of governance paralysis. And again, like, it's up to you to judge if that's good or bad, right? But, well, the fact is the fact. We have some off-chain covenants, like, kind of us as kind of the Bitcoin in general, kind of, right? Bitcoin has some off-chain covenants. DLCs, some pre-signed base tricks. Well, this is one more trick. It just gets you more functionality. So what we thought about and what we know we can do, like with the V2 right now, is basically the replacement, pretty straightforward replacement for CSFS. So actually, I hate to say that, but CSFS BIP can be now deprecated. Sorry, because you don't need it. Upvolt BIP, well, it already got deprecated, but yeah, you can do vaults as well. CTVN, whatever, and all of the other interesting opcodes, it's more tricky, so don't deprecate them yet. We might still need them. Yeah, so also I would say, like, besides, kind of interesting fact that besides kind of inducing the covenants on Bitcoin, Pipes induced, well, by accident, pessimistic ZKPs on Bitcoin, like non-interactive ZKPs on Bitcoin. We already have actually ZKPs verification on Bitcoin in an optimistic manner. Like BitVM people actually employed that very, very well. So this introduces non-interactive ZKPs. Single transaction verification. Sure, adjustments for finality and forks and all that stuff, sure, but it does what it does. Yeah, and like this is a little bit of a thing which Pipes enabled because of this pessimistic verification. Well, we tried to call it consensus verified meta protocols, but it actually makes meta protocols to be able to use Bitcoin inside of them now. BitVM also does that, like just to be completely precise here, completely transparent, BitVM can also enable that. But there is always dispute window, there is always a lot of optimistic assumptions, a lot of different stuff. So we hope this will allow for meta protocols to be a little bit more fun again. And actually, Pipes brings some implications for Bitcoin L1 itself, because certain stuff now can be done off-chain, pretty sophisticated behavior in comparison to DLCs or like pre-signs. The Bitcoin L1 itself can start being simplified. Like, again, as I said, don't overcomplicate the protocol. Don't touch it. It works as it is. It's fine. So effectively, you don't need all of these arguments about new opcodes anymore. Like, really, people can just get what they want without adding new opcodes. Just focus on security. Like, focus on post-quantum. The core people, dudes, fellas, folks, focus on post-quantum, focus on security. Don't waste your time on opcodes or bullshit. So that's the thing in here. And yes, like if we trick around and like screw around, this like Pipes might and well, probably will bring something new or some new properties to Bitcoin L1 itself. Like whatever, privacy, for example, or like pooled, or like pools, right? Pooled collateralization, or whatever there is, right? If it's good enough. Well, somebody will design it, like the pipes are there. Cool, that's what it is. I'll talk more about it on the dev stage. We'll talk about nuances if you want to. We might do some whiteboarding. Come to talks, and like, welcome to OPNEXT. Like, we should have like questions or whatever. No? No, I don't think so. All right, well, come to the talks.
Who in the world is mining Bitcoin in Australia right now? I mean,
I don't like a company going bankrupt, but whenever something like this happens, you can go into Pacer, find the court filings, and then you have all of this juicy open source information about who is involved in these things. Some of the names that have surfaced from this, there's some really weird stuff in here. Like, for instance, is the Chicago Blackhawks hockey team?
Hey, y'all, we have a 15-minute break, and then we're going to kick it off with Nick Hansen of Luxor, and he's going to talk about Bitcoin mining and quantum and why miners should take a look at the Hourglass proposal. We got coffee, we have tons of food outside, and there are a lot of people in the lobby, so go say hi to some familiar faces. We'll be back here in about 10, 15 minutes. I think it's 10:30 on the spot right now, so we'll kick off with Nick in 15 minutes. We have 2 more talks before lunch after that break, and then we have programming the rest of the afternoon. We'll close up shop at 3:45 after all those talks and head down to Pub Key at 6 p.m. for some beers, burgers, and hot dogs. So take a break for 15 minutes or keep crouching on your chair. That works too if you're enjoying that. Thanks all for joining us at OPNEXT 2026.
Alrighty, y'all, we are back after that brief break. For our next talk, we have Nick Hansen, the CEO of Luxor, talking about forecasting Bitcoin's security budget, and with a little surprise that might trigger some of y'all on how quantum computing might indirectly fix this problem.
Thank you, Colin. All right, welcome everybody. All right, let's see. Oh, hey guys. All right, slaying the white whale. Yes, this is going to be an interesting talk. I hope I don't get booed, but don't slay me. I'm just the messenger here. So anyway, my name is Nick Hansen. I'm the CEO of Luxor. We build mining pools and all sorts of mining infrastructure. Thank you to Con. There he is. Thank you to Con for helping me put together this deck. He did a great job researching it. We actually had to kind of rewrite it multiple times because new information keeps coming out so quickly on this topic. So all right, let's see if the clicker's working. Amazing. So we are advocating here for protecting Bitcoin's market integrity during a quantum event. So I am advocating for something up here. But I don't actually advocate for anything about the future. I'm not talking about like what types of signatures we should use going forward or any of those types of things, because I don't know, and maybe nobody really knows yet. But I am telling you that there is a problem that's going to be a big challenge for us, and there's a way, I think, pretty elegantly to incentive align with the kind of the solution to that problem. I do have to show my products just a little bit. We build mining pool firmware, fleet management called Commander. We buy and sell mining machines. We finance hardware, and then we have an energy desk, all of those things. So if you are a miner and you don't use any of our Luxor products, please do. Thank you. All right, so now I can expense this trip. Okay. So the white whale, I'm sure I'm not the only one that's going to talk about it. There's a lot of people here that are talking about it. We were at the BitDevs last night talking about the quantum threat to Bitcoin. As of today, there's about 6.7 million coins that could be stolen if a quantum computer showed up today. But we're going to be talking about a specific group of those coins and how they might end up actually flowing to miners. So I'm sure you've all seen this. This is an incredible site to kind of display the problem that we're facing right now. As you can see, there's about 6.9 million Bitcoin that are currently susceptible to quantum attack. What that means is they can get the private key from the public key that's been exposed through a bunch of different ways, and then ultimately spend those coins to themselves, which is kind of the opposite of what Bitcoin is supposed to do. You shouldn't be able to do that really. When we bought Bitcoin 15 years ago, we were told nobody can steal your private key, but now they can. Well, kind of can. So there's really three paths forward for what to do with those coins. Option one is just do nothing. We just let Bitcoin continue to run. I'm pretty sure most of the people here probably advocate for doing nothing. That means the coins will just get stolen, most likely market liquidated, and that could be catastrophic to the market structure of Bitcoin for a long term. That's kind of the con of this happening. The pro is that Bitcoin is unconfiscatable. You shouldn't be able to do that, stop people's coins. The other option is to burn or freeze. So after some period of time, you basically turn those coins, make them unspendable. Spending them becomes a consensus rule that you can't break, or I guess would break the consensus if you do spend them, effectively freezing them, removing them from the supply. Of course, that goes against Bitcoin. I think this is probably the worst, in my opinion, the worst of all the options, but it is an option. It's being advocated for in 361. There is a third option, which we're going to get into, called Hourglass. I don't know if anybody's ever heard of it, but basically it limits the spendability of some of those coins into the future. So we'll say there's a 5-year horizon where anybody can spend any coins, but after that 5-year horizon, we put some limits in, and basically allows you to only spend 1 Bitcoin per block. So you can only steal 144 Bitcoin per day, helps maintain market integrity, and actually most of those coins will end up flowing to miners, and we'll talk about that here in a minute. A little more detail, yeah, so option one is let Ahab sail. We do nothing. Let the quantum attacker sweep the exposed coins. You can read the slide here. Honestly, I think this would be a massive detriment to Bitcoin's value proposition long term because it breaks, basically breaks the market at the end of the day. Bitcoin is US denominated, and we have to pay bills and things like that. And most folks would be like, well, that's a very high time preference thing. Let the coins be stolen, let the market reform, let all that capital reform, and The problem is I am high time preference, and actually everybody in here, whether they liked it or not, is high time preference. And the reason for that is because you all have an expiry date. I do as well. And I am high time preference for that reason. And so I don't know, I'm very certain that if we let the coins get stolen, that Bitcoin will eventually survive and last long term. The problem is I may not get to see that. And I'm not sure my kids would get to see that or their kids. It's unclear how long that would take. But it wouldn't break. You know, Bitcoin would continue to run. And so that's what a lot of people will talk about when they say we should do nothing. Of course, you can burn or freeze them. Obviously, this is highly politically radioactive. And the philosophical argument is that nobody has the right to seize your coins. I don't think you would get people to agree to this, but it has been proposed, and it actually is getting some traction. So let's talk about Hourglass, which is actually the reason I'm here to talk about this. So if, I think the philosophical argument is really poignant here, because if we must choose between chaos and confiscation, there is a third way. Having some order to this, I guess, I'm gonna call it theft, but some people say it's not. Having some order to this theft could actually really, give us the best of both worlds, and ultimately, those coins end up flowing to the most aligned holders anyway, which is, I think, important. And yeah, we're gonna get into why this is a minor problem now. So, if you don't know what an RBF is, you can see it here. RBF allows you to more or less prioritize your transaction with higher fee. So if I send a transaction with 1 sat per VByte, but the mempool is much higher than that, that transaction never gets cleared. I can replace that transaction. The RBF stands for replace by fee. I can replace that transaction with a higher fee, and it will get prioritized in the block, and it's basically first to show up in the block wins. And so that's how RBF works. Miners will prioritize it higher. That's important because, well, I guess I just explained what RBF is. Why that is important is because what's going to happen is there will be more than one quantum attacker. Let's just say Google in China. And what ends up happening is that they will RBF each other, because they will each have the private key for these stolen coins. And so they'll RBF each other, and so the RBF will then increase basically up to some amount below the value of the outputs, let's say 1 Bitcoin. It'll start at 0.1 BTC to 0.2 to 0.3 to eventually reaching a terminal value where eventually the block clears and the majority of that output then flows back to the miners. And everybody here should care about that, and the reason for that is that miners are the most incentive-aligned holders of Bitcoin, and they're really the only ones that can participate in this. There's really kind of 2 folks that will end up getting this Bitcoin if it's stolen. The attackers, who now have to pay back the capital expenditure for billions of dollars of R&D and however much money it costs to run these quantum computers. That's like a massive problem. They're going to immediately liquidate those coins. And they're going to get stolen. Like, that's going to happen. They could flow to the miners, who, of course, they do sell coins. We've seen Marathon and Riot and those guys all selling coins now recently, but generally they are pretty good holders. So they're pretty good stewards of this stolen coin. And if they're going to get stolen anyway, maybe we let them flow to miners. And so I can see, here's kind of a timeline of all the events that are potentially happening. And then really the last point there is that the realistic activation for this would be probably like 2028, 2030 or so. Gives people a lot of time that are quantum susceptible now to migrate to new addresses. Again, that's a topic for much smarter people to talk about, like what kind of addresses should we be using? How do we protect the Bitcoin that is savable prior to this attack? And then a little bit of information there on how long it would actually take. And the reason this is important is because it actually is adding. If you buy into this idea that that the blocks, that the coins will ultimately flow to miners, it actually juices the block reward for about 32 years. And me as a miner, I kind of view the security budget as being a pretty big problem. We haven't seen the security budget increase alongside as we would expect, because there really is no transaction fee volume outside of like the ordinals and runes craze a couple of years ago. But other than that, we haven't really seen any sustainable fee market form. That is an existential problem for Bitcoin long term, or at least I believe so. Some may not believe so, but I do. And that's something that we don't really have an answer for. And this kind of solves it for what I would say is the rest of my professional life. If after 32 years I'm still working on these problems, something's gone wrong, and I'm not, I didn't plan well for the future. But the idea would be that, for the rest of my professional life, there is now at least some subsidy going to miners that will help us get to more of a final resolve for that challenge. So it kind of solves you kind of get two birds with one stone here. The coins actually flow to incentive-aligned holders, and it also solves a challenge for the security budget that we don't really have a solution for, at least for the majority of our lifetime. And so I'm a big fan of Hourglass. So yeah, we're probably going to start seeing miner signaling support in various ways for any of the proposals. I mean, I would say probably over the next 2 years would be a good time frame for that. Yeah, if you do have customers, you need to educate them on how they should be using Bitcoin today. Don't use P2PK. Stop reusing addresses. Basically, if you reuse any address, you end up exposing your coins to quantum attack. And then, yeah, signature schemes. We got to be thinking about what to do going forward. Again, that's probably other people's topics. And so that's why I'm saying we should tame the whale, which is a nice hybrid approach between letting all the coins just hit the order book and then also confiscating them. So, because yeah, at the end of the day, these coins are going to get stolen, and I think Hourglass is a nice way for them to flow to folks that are at least aligned with Bitcoin. So. I do actually want to leave, I think I only have 1 minute, unfortunately, but I want to leave a little bit of time for questions, because I imagine there are some folks that have questions. It's hard to see with the lights. I think there's one over there and then one over there. Maybe you might just have to shout it. I'll repeat.
I got a quick one. Does the logic require that you have 2 quantum attackers so that they're bidding up with RBF? Like if there's a single quantum attacker?
Yeah, so the question was, does there have to be 2 quantum attackers? Yes, there needs to be 2 private keys exposed for this to work. In my theory, or in my view, there will be multiple quantum attackers at a time. Google, of course, is probably going to be the first. China has said that they're maybe 3 to 5 months behind Google. So even if for the first 3 years it's just one attacker, there will eventually be multiple attackers, and there will be incentive for them to RBF each other. I think I have time for. No, I got time for one more. Yeah, let's go. All the way in the back there. No, because that's really outside of. I think that's really outside of this attack vector. Also, I think that's highly less likely. Though it is a valid point, and I do understand where you're headed with that. But I think that's something that I guess like a country kind of reached a consensus, not the globe. I don't know if you like that answer, but it's the one I got for you on my heels. One more question. Or not. Great. I was really expecting to get like a lot of boos, a lot of people yelling at me. Yeah, RBF is basically an auction. So if you go and spend your coins today, and you say, oh, I put the wrong fee in, you will then sign a new transaction with a higher fee rate, and that one will then get confirmed. You can do this multiple times. Actually, during Ordinal's craze, some folks in here built tooling to it's called sniping. You're basically bidding it up and then trying to be the highest fee, because the highest fee in the block, or sorry, the highest placement, which is generally ranked by fee. You could subvert this with miners, and don't need to talk about that. But anyway, it is like an auction, yes. Yep. We got red shirt there.
What do you think of just having a fork and letting a market figure it out with like a futures market or something like that?
Yeah, you could fork. You could fork. I was a pretty big part of the last fork, I guess, as a miner, not an executive in any capacity. Just it was a juicy time to be a miner. It was great. Miners would love a fork. I imagine that. Miners are purely profit driven, as much as we want them to be. Yeah, 2017. Yep. Yeah, Taproot was not contentious in any way. SegWit fork was. Yeah, I mean, you could let a fork happen. Unfortunately, that kind of you don't really know who's going to win, and that could introduce like a lot of uncertainty. But there's going to be two. There's going to be two Bitcoin. There's going to be two Bitcoins at the end of this. There will be qubit quantum Bitcoin and not quantum Bitcoin. And then I guess at that point, you're right. We will decide who wins. But there will be two Bitcoins, I guarantee. At least two, probably more than two. So. So that is a freaking great point. I didn't even think of that, and that's why putting this together has been really fun because so many people have really great ideas about what the possibilities are here. That's absolutely a possibility. The challenge would be I don't think quantum computers will be able to crack a private key in 10 minutes. I think this attack vector, they'll basically go and crack all of those private keys and then have them cached, ready to activate whenever it's time. So I don't know, but if they get fast enough in the future, that could be a massive problem in the future. But yeah, that's a great point. I never even really considered that. Maybe miners will be saved by quantum attacks. So I think they're ushering me out of here. Yeah, my name's Nick Hansen. I appreciate you guys listening and maybe not booing as much as I thought you were going to. So, all right, thank you guys.
Who in the world is mining Bitcoin in Australia right now? I mean,
I don't like a company going bankrupt, but whenever something like this happens, you can go into Pacer, find the court filings, and then you have all this juicy open source information about who is involved in these things. Some of the names that have surfaced from this, there's some really weird stuff in here. Like, for instance, is the Chicago Blackhawks hockey team? This is real for 1.26 million.
At first blush, might be like, well, yeah, of course, just, check the boxes, dude. But if
just
you
log the trade, bro.
Yeah, just log the trade. That's not how it works.
Now, this is very much a he said, she said story.
Riddled with drama.
Anchorage Digital is a platform for everything that an institution could need in order to interact in the digital asset ecosystem. If you are someone looking to buy assets, looking to hold assets, looking to stake, collateralize, trade derivatives, we provide the entire full suite, one-stop shop that any institutional investor might need in order to utilize digital assets. We have 1,000 clients on the platform and growing more every single day. And we are increasingly expanding the offering to support institutions looking to build businesses in the digital asset ecosystem. Folks that are looking to utilize the platform in order to integrate it into their bank, into their fintech, into their offering. That part of our platform is growing really nicely. And then additionally, we are getting big into the stablecoin business, looking at how to allow people to issue stablecoins, how to settle stablecoins, how to move stablecoins in the ecosystem.
Who in the world is mining Bitcoin in Australia right now? I mean,
I don't like a company going bankrupt, but whenever something like this happens, you can go into Pacer, find the court filings, and then you have all this juicy open source information about who is involved in these things. Some of the names that have surfaced from this, there's some really weird stuff in here. Like, for instance, is the Chicago Blackhawks hockey team? This is real for 1.26 million.
at first blush, might be like, well, yeah, of course, just, you know, check the boxes. But if
Just
you
log
are
the trade, bro.
Yeah, just log the trade. That's not how it works.
Now, this is very much a he said, she said story.
Riddled with drama.
Anchorage Digital is a platform for everything that an institution can.
All righty, y'all. Thank you for hanging in there. Love to see those seats filling up. We've got one more presentation, or talk rather, before lunch, and it's going to be an investor talk on the quantum threat and what some of these firms are doing to address it. For this panel, we have David Duong of Coinbase, Robert Mitchnick of BlackRock, Raghav Chopra of Tefra Digital, Boaz Avital of Anchorage Digital, and I'm your moderator, Editor-in-Chief of Blockspace, Colin Harper. Please welcome our panelists to the stage. Gentlemen, thank you for joining us. Before we get into the meat of the discussion, could y'all just give everyone a quick rundown of your names, titles, and what you do at your respective firms?
Yeah, I'm Dave Duong, Global Head of Research at Coinbase. I've been with Coinbase now for 4 or 5 years.
Robbie Mitchnick, I'm the Head of Digital Assets at BlackRock, been there since 2018.
I'm Raghav Chopra, co-founder of Tefra Digital. The firm was started over 4 years ago and have been on Wall Street a couple decades before that.
Boaz Avital, I'm the Head of Product at Anchorage Digital. We're a digital asset bank for institutions to custody their Bitcoin and other digital assets. I'm part of the founding team, so we've been there since 2017.
Alrighty, so I feel like there are fewer topics more divisive right now in Bitcoin, perhaps, than the quantum computing debate. You know, we were tearing each other's eyeballs out about filters for about a year, so I'm happy that we're moving on to something a little more productive. But it's really, the conversation's really started taking off, and it's incredibly divisive of people thinking that we're too early to this, that quantum computing might even just be a scam, and other people saying it's better to be early than late to something like this. So to open up the conversation, I would just love to hear y'all's perspectives on how much of a concern this risk is within your specific organizations, or if it's being addressed as a concern, and how long it's been on y'all's radars. So David, we'll start with you and then move down.
Sure. So I would say, if we roll it back to 18 months, 24 months ago, I think we were treating this the same way a lot of people were looking at it. We're like, if this is going to be a problem, this is not going to be a crypto-specific problem. This is going to be one that's going to be affecting traditional finance, banks, et cetera. And I think we've kind of come around to the idea that actually, as a decentralized protocol, like this is actually much more concerning to us than if you were a bank or a large financial institution that could air gap it. So things have changed. I think the conversation that we used to have with clients, many of them kind of put it in the back burner, and a few things happened in order to get us there. You know, like Robbie's going to speak next, but you know, like BlackRock putting it in their ETF filing, for example, was a big one. But then we also saw the papers that were coming out, the fact that NIST actually has put the migration deadline at 2030, 2035, Now, of course, we have the Google and Caltech papers as well. So I would say increasingly, this is one where we still believe this is a solvable problem. This isn't one that's going to like tank us talking to investors, for example. No one's using this as an excuse to say like, well, I can't buy Bitcoin because, you know, like this exists. But a lot of these institutions have timeframes of like 3 years, 5 years, 10 years. They are long-term thinkers. This is not something that they want to hear down the line, like there's going to be a problem, and at that point, you're going to race to try to solve that issue. They want a timeline now to start tackling this issue.
Yeah, I think maybe less pertinent than the level of concern and focus on this within BlackRock itself is what we are seeing from our investors. And I think that a year ago, this was totally off the radar, not a topic that came up other than on, I would say, very remote occasions. Now there is a clear trend toward this being more top of mind for more investors. The good news is, I agree with you, David, that it is an eminently solvable problem. That's our view, and it's about taking the proactive steps now to have a plan, to make clear that there is a plan, and when that occurs, I think that it's going to put a lot of investors' minds at ease. But the narrative out there of, you know, it might happen, it might not happen, and merely arguing over what the timeline to it is, does not put, you know, any prospective investors' mind at ease.
So Tefra is an investment firm, and we take an institutional approach to the world of digital assets. And this particular topic has been one we felt has been important and not to be dismissed, but very much resolvable. So from experience as an enterprise software investor, I'd say this is power of open source on full display, where the durability ultimately comes down to the fact that open discussions on the different proposals can happen. And that's actually an advantage in the long term, even though the path can involve many debates. We've put out 2 papers. This has been something we've been focused on for some time. And we don't advocate for a specific path. I think obviously BIP 361 is very recent, and that's come out and added to prior work and proposals. But we think that investor focus is increasing on this topic, and the asymmetric promise of Bitcoin in terms of appreciation also dovetails with people who are looking to start positions not wanting tail risks to be there. And so the pace of capital deployment, I think, is influenced by making sure that tail risks, particularly those that are very technical, which most investors often feel they can't diligence or get the answer to, don't become a long-term boogeyman. So I'd say there's a real imperative to accelerate and continue the work to be post-quantum ready, and that's important for institutional investors.
As like a safety, security first company, we have the benefit of having folks who are independently interested in cryptography and research, and so we've had threads about the upcoming sort of potential quantum transition for well over a year now at Anchorage. And it's certainly, like everybody else has said, the narrative has gotten louder and the need has gotten louder over time. Our position has always been, how do we make sure that any changes to digital assets that happen, we are ready for them well ahead of time. That's what customers look to us for, especially when it comes to the safety of their assets. So when we think about it now, and certainly more recently, we want to talk about not just what are we doing with Bitcoin as it exists today to make sure customers are safe, but how are we contributing to make sure that Bitcoin itself has a transition to being safe over time. And I would say that's been the biggest change over the last months. The whole community, not just core developers, but the whole industry is getting into the discussion and into the proactive research.
So Robert and Raghav, y'all both mentioned that you have investors and clients starting to inquire about this and bring it up in conversations with y'all. Robert, we'll start with you and then move down and give all of y'all a chance to answer this. But I'm curious, What do those conversations look like? What's the frequency? What share of or portion of investors are asking these questions? And what kind of questions do they have when they're asking y'all, okay, so this appears to be a problem. What do we do next? What kind of questions are they asking?
Yeah, so one of the incredibly attractive things about Bitcoin historically, and I would argue in many respects on a go-forward basis too, is asymmetric risk-return upside. And that's also borne out in the data. That's been a uniquely positive skew asset where the right tail is much fatter than the left tail. And that's attractive to the marginal adopter in many respects, has been for the multiple cycles in Bitcoin's history. Quantum is a curveball because it kind of inverts that, and it potentially caps the perceived upside so long as there's a sort of at least narrative or risk overhang in the market, and widens the left tail in the potentially really bad scenario. When you combine that with what's happening in AI, which is sucking oxygen out of just about every other investment category today, and in some cases, you could argue rightfully so, it's a particularly precarious time from an investor narrative and sentiment perspective to have this sort of overhang at play. Like I said, it's solvable. I think the thing that a lot of investors are looking for is not certainty over exactly how quantum plays out and on what timeline, but the notion that there is a plan, and here's what the plan looks like, and here's how one can reasonably expect it to play out. One thing that I think is not helpful is arguing over timelines, and in particular, when those within the Bitcoin community have a timeline view that is outside of where Google is and where expert consensus is and other things, that doesn't typically come across as credible to a third-party observer. And so whether that turns out to be right or not, that actually maybe the timeline is longer than consensus is now said, the narrative issue remains, and that's not going away until there's evidence that there is a plan.
Yeah, I think investors are broadly interested in a range of themes and technologies, and there's often greater convergence rather than a fight between these. So if you think about Bitcoin as digital capital, this is so suited for an AI future, and that, in fact, is a self-reinforcing function that we see and expect. So I'd say investors are interested in the ideas of AI and quantum as much as blockchain and how they're intertwined is still being discovered and appreciated. I'd also say that the inverse of an overhang is a wall of worry. So in a lot of markets, sometimes it's actually a great setup, because as that worry is eroded and you reach a resolution, that creates opportunity to the upside. And I think as many investors that may consider the quantum risks that in the moment seem large and looming are also thinking about, as this gets resolved, that's potentially going to unleash capital. So we look at it from both sides. And I would say that part of it is, of course, perception. And so markets are interesting, right? The perception can become the reality. And a lot of the perception has been very blockchain focused in terms of quantum risk. But if you think about the broader ramifications, even centralized organizations and systems, I mean, there's a lot of exposure there. And the openness with which they adapt is also an unknown, which the transparency of Bitcoin and open source software provide, and other systems may not. And so I think it's not so clear cut that there's going to be a direct and continued and sustained and unending opposition because of quantum. And what's changing now is that events like this, which bring progress and development back into the public eye, may help reframe this sense that not much is being done about it, or people are just going to wait for decades. So I think even in the last few months, we've seen a big change in terms of progress and discussion towards reaching resolution versus ignoring it.
So what do customers ask us about when they're coming to us to talk about the quantum risk? You can imagine if you have hundreds of millions of dollars, billions of dollars of Bitcoin with us, you've done a lot of legwork to educate yourself about what is going on in the space. And a lot of the narratives in the space definitely raise a lot of hackles, like, is enough happening? Are we as an industry moving fast enough? So the questions will bundle around a few different areas. The first is, what are you doing now, right? If Bitcoin isn't currently forked to be quantum safe now, what are you doing now to keep me safe? And they know that there is public key exposure risk that we want to avoid, and there's different mechanisms to avoid that for the customer. And Anchorage has always been, used addresses that don't expose public keys, and has always used Bitcoin conventions from day one to minimize address reuse, which has been just the normal privacy conventions that it turns out to help here already. The second is, what are you doing to get ready for when Bitcoin is going to be quantum safe? And that's where a lot of companies have a hard time, I think, answering that question, because there's so many unknowns. For us, that looks like staying on top of the narratives in the community and the research that's happening. It looks like being proactive in setting up our custody solutions to be ready. So we've already benchmarked all the current NIST-approved post-quantum cryptography algorithms in our HSMs, so that when one is chosen or a similar one is chosen, we can migrate to those very quickly. And the third is around having the agility to actually do that. So it is very important for any migration, for any kind of blockchain, and now here we are with Bitcoin going through a big migration, potentially, hopefully, in the near future. How are we going to get you from today to tomorrow in the fastest and easiest way possible? The customers can't do this for themselves, so we have to do it for them, and we have to be ready when that's there. And then the third is, how are we going to make sure that Bitcoin does get there? How are we going to help? So we want to help by contributing with research around soft forks, with research around reducing the on-spend problems for potential on-spend attacks for when we do get to a migration path, and helping put our weight behind and our brain power behind, and ideally our dollars behind the places where the best and fastest research can happen. What I wish they were asking, that they don't ask quite enough, is, we're focusing on Bitcoin, but this is not a Bitcoin-only problem. This is a cryptography problem. So it's not just Bitcoin itself or the custody, the private key custody that needs to be evolved. It is also for folks like us, your crypto bank, all of the things around how are you being prepared so that your entire security lifecycle is ready for a post-quantum world. And that means, we've already deployed quantum safe TLS, but there's things up and down the stack that every single company needs to look very deeply at how instructions are transmitted and executed to make sure that crypto is safe. And it's also true for every other security-focused part of your life. Whether it's your other bank that you use, whether it's your password manager, whether it's the pictures on your iPhone, right? All of this stuff is going to be exposed, and we all need to solve this Y2K problem as an overall tech industry together. The other thing I wish they would talk about is what's next. Like, this post-quantum migration is a scary thing because we're unsure whether we're going to make it. But we will, of course, make it. It is way easier to make Bitcoin quantum safe than it is to build a freaking quantum computer that can factor large prime numbers. Like, we're definitely going to get there. And then what does crypto look like? Because right now we're talking about conventional cryptography that is post-quantum. What does a quantum cryptography blockchain look like? What kind of security guarantees do we get when Bitcoin, another crypto, moves to a quantum world? And then how much better and stronger does that make this whole concept of global blockchains when you have that level of physics safety behind it?
Yeah, so When Will and Colin asked me to be on this panel, I don't know, a month ago, 2 months ago, I had a very different vision of what I was going to say to this audience when it came to some of the client questions and other things. And part of that's just because the world is changing so quickly. I mean, even over the last week, I would say that we've seen pretty good progress, actually. I mean, like, it's not all been bad news. Like, we came up with, what, 5 proposals over the course of the last week and a half on how to tackle post-quantum solutions. Some of them are going to be more difficult to implement than others. But to Boaz's point, you know, the clients that we speak to, I mean, they're getting a lot more sophisticated. I've been doing research for the better part of like 20 years, and that's been mostly in the TradFi space, doing macro and other stuff. I was a quant strategist for a while. When I started in crypto formally, I would say that the knowledge base was like Crypto 101. Like, people had very little idea about like what was actually going on in the background. They believed in the value of Bitcoin and the proposition there, but they didn't understand like, what's Taproot? What's this? Like, what, like, you know. Now they're kind of like, hey, how are you not solving the quantum problem? Like, Taproot took 7 years. Like, you guys gotta get on this. Like, this is where people are at these days. They are familiar with the difference between ECC and SHA-256, and they're like, oh, I don't care about SHA-256 as a mining problem. I care about the wallet issue. Tell me how the community will deal with that. Oh, it's a self-sovereignty problem? Okay, fine. Then like, let's have a discussion. Why won't people have discussion? You know, like, these are the questions I think clients are pressing on. But to Robbie's point, I think it's an absolutely important one. The timeline question, I think, it's not helpful anymore. I think that it's important to kind of keep an eye on it to know, like, hey, where it is. But for the most part, not even the experts know, because there are 2 or 3 separate groups of experts here, from the physicists to the computer scientists to the people in the crypto space, and all of them are seeing a different piece of it. So some of them think that things are moving faster than others. So I would say the timeline is still fairly nebulous. Having a discussion on that isn't going to help us to say, like, oh, guys, it's 10 years down the line or 20 years down the line. Like, you know, Peter Shor thought that this was going to be 20 years before we would have a quantum computer that could actually viably crack like RSA or ECC. Well, we know that like that timeline is being pushed up. So the pressing issue really is, let's have a discussion. Like this week, like, you know, yeah, I think like you mentioned like the BIP 361, for example. Okay, let's have that discussion. It's not going to be an easy one. We're not comfortable with it as a community, but we just need to have a discussion and actually formally recognize it, which, of course, being a BIP, it actually is. But, I mean, other things, too. I mean, the announcement like that we saw with, hey, there's actually potential for having a non-soft fork solution to this. It's very expensive. It'll be like $200 a pop, but, like, okay, like, at least that's a good kind of way to set the floor for where, like, the biggest risks are. So I think that this is what our clients are coming with. They're a lot more sophisticated now than they were 4 or 5 years ago.
And I would say just maybe one point on the timeline piece, because I think it's a pitfall that we should be wary of. I'd use the analogy of if you're a commander defending a fort and you get intel that there's going to be an enemy attack likely between midnight and 6 a.m. with the most likely time window being around 3 a.m. You wouldn't say, okay, great, we'll have the troops on the sentry at 3 a.m., right? So there's this uncertainty, and unfortunately, you know, whether it's 2029 or 2030, 2032, 2035, whatever one believes, there's uncertainty in the time distribution. And we can't aim for the middle of that distribution unless we're accepting, you know, 50, 60% probability of a real problem based on where it actually lands in the curve. Now, of course, there's not zero cost to moving proactively, perhaps too soon, right? And so, you know, we hear that a lot, and I think it's valid. But the good news is that 80% of the planning and the work and the socialization, I think, can be done without having necessarily finalized, say, the final post-quantum signature algorithm or other elements of the plan, but that we can get much further down the track even before there's consensus that it's time to pull the trigger.
So y'all all kind of touched on the periphery of my next question, which is in regards to the actual development timeline for this. And Robbie, as you pointed out, investors like consensus, markets don't like uncertainty. And as anyone in Bitcoin can tell you, Bitcoin developers, especially those working on the core protocol, kind of march to the beat of their own drummer. And for a long time, it was mostly fine. Something like Taproot, right, is pretty esoteric for most people investing in Bitcoin. It might be unscrutable to some. But now we're in an era where Bitcoin is more institutionalized than ever. It is held by more people than ever. The market cap of Bitcoin, I mean, is not at this all-time high, but the stakes are much higher now for anything else that's come before it. And when it comes to quantum, you know, as y'all know, managing assets for multiple high net worth individuals, the stakes are even greater, you know, for the people who have been coming in more recently. So leads into my next question, and Boaz, you even kind of already touched on it by saying, you know, your Anchorage is thinking about how do we allocate research man hours and how do we allocate maybe dollars spent towards this problem. So I'll start with you, Raghav, and then we'll move down. This will probably be our last question. Do y'all anticipate that your firms and other firms of your caliber will have a more hands-on approach to this upgrading cycle for Bitcoin than in upgrades past?
We're market participants, but I think there's a very big difference between the Bitcoin of many years ago and today because you have very well capitalized firms that also have incentives. And so therefore, we won't just unload it on BlackRock and Coinbase and Anchorage, but I think that's very important because a lot of these proposals come down to this fundamental question of internalizing the private cost of an upgrade or upgrades. And I think some of the protocol upgrades across blockchain have often adopted that model. And here, I think there's a coordination difficulty, and there's all the benefits and speed considerations of the open source model, but the leadership continues to be demonstrated by important firms in the space, and I think that's helpful because Taproot certainly took a number of years, but now in balancing decentralization, but still having some strong actors that have economic incentives to see this through and make sure that risks are mitigated on the correct timeline is great, and that's additive. And so, Coinbase has events on quantum that they're planning as well. BlackRock has been transparent and vocal, and the custodians are already planning for the best mitigation strategies. So all of that's good, and it's different from before where there weren't private firms that had the capitalization and resources to do the upgrades.
I 100% agree. It's just not the same Bitcoin. It's not the same Bitcoin of the Blockspace wars where, the industry was very small compared to what the community wanted. It's not the same thing as Taproot where, adoption of anything is based on demand, right? Here we have a clear need, a clear demand, and, the strategies of the world, the BlackRocks of the world, the Anchorages and the Coinbase of the world, we are a part of this community now. And Bitcoin is a community that is working towards developing these changes. And so it's on all of us to do that. And there's no reason why it shouldn't happen. One thing that's, I think, very important here is that we aren't going to wait for some other external change, right? We are going to come and make sure that we all execute this in time, in a timeline that makes sense for us as a community, not just some other external timeline.
And so Bitcoin is very important to me personally. It's become more important to BlackRock over time. At the same time, we're very wary of the idea of a large centralized financial institution trying to play too proactive a role in issues like this. And so that caution will very much inform, how we try to participate. But ultimately, consistent with anything else related to Bitcoin, we're trying to, now as the largest Bitcoin fund manager in the world, be a supportive, helpful actor in the ecosystem and finding our way in terms of what that looks like in general and on this issue in particular. And I think as the firm that as the financial firm that's brought the most new investors into Bitcoin in the world by a large margin, we also have a responsibility to stay very close to this and also make sure investors understand properly and with nuance the risks that exist and how they evolve.
Yeah, from Coinbase's perspective, we've been trying to take a larger role with respect to this issue. We launched the Quantum Advisory Council, for example, earlier this year. We are putting out active white papers on the subject. And we want to recognize that, this isn't something that we want to see like a rush to like implement, for example. We're not looking for a solution to be done this afternoon. In fact, quite the opposite. We recognize that rushed implementation could actually pose a larger security risk to the ecosystem. But we're not just looking at Bitcoin, we're Coinbase, so we're in a large crypto exchange. We're looking at what's going on with Ethereum and Solana and other things, and we've noticed that other ecosystems are already putting out schedules on how to kind of deal with this stuff. Solana actually, weirdly enough, like I don't think a lot of people know this, they're actually pretty far along. They did realize that the solution that they implemented actually would create a huge transactional problem for them in terms of speed. I know we're here to talk about Bitcoin, but just telling you, like, this is kind of what our investors are kind of looking at and saying, like, well, hold on, like, why is Bitcoin not working? They're the largest, token, the largest project in the crypto space. Like, why is Bitcoin not actively kind of dealing with this issue? So that's kind of the front that we're looking at. Yes, like internally, we're also looking at like, how do we audit this stuff? How do we make sure that we're quantum ready? Like how do we make sure our custody procedures are prepared for this? But we also understand that like this is a larger community discussion that we need to have.
One thing that is really important is that on the Bitcoin community threads, people are talking about this. It's not like the Bitcoin developers are completely, oblivious off working on something else. There is a lot of active and excited discussion around quantum. It's just Bitcoin doesn't have a marketing department like we all do. And so, they don't have the benefit of being able to have somebody out there touting, here's all the things that we want to do. They're doing hard research, and that's what they need to do.
Gentlemen, thank you very much. Let's give it up for our panelists, y'all. And with that, we will be taking a break for lunch. We'll be back in about an hour, so go get some grub, y'all. All right, welcome back, y'all. Hope everyone had a good lunch. Kicking off our second series of talks is Alex Pruden of Project 11. He will be talking about what we can do to address Bitcoin's quantum computing threat.
Hello, everyone. It's a great pleasure to be here. This is my first OPNEXT, but I'm very excited to present. And actually, I hate to disappoint you. I'm not going to be talking exactly about what we can do to address the threat, but I want to do something I think maybe that's even a little bit more important before we talk about potential solutions. I want to talk about the threat model, and in particular, I want to talk about quantum computing and how I think about it and how I think about how it is developing, right? Because I think one of the biggest questions that we have to consider as a community is, what is the solution, but also over what timeline do we have to implement it? So I hope you find something useful in this talk. I hope you all learned something. And without further ado, okay, let's get into it. What is a quantum computer? A quantum computer is a special computer that uses quantum mechanics. The quantum mechanics that it uses or the special properties that it uses are all listed on the slide. I actually don't think it's a good use of time for me to tell you what these are. You can go to ChatGPT or your favorite LLM to kind of give you a quick crash course on these various properties. For the purposes of this presentation, I think the more important way to consider what a quantum computer is so, compared to a classical computer, a classical computer can just compute things, right? Quantum computers can compute certain things faster than a classical computer, but not everything, okay? And what are those certain things? Well, thanks to this gentleman right here, Peter Shor, who is a mathematician at Bell Labs and later MIT, we know of some algorithms, or an algorithm, that is relevant to potentially the cryptography underlying Bitcoin. So this is Shor's algorithm, not to be confused with Shores with a J, the contributor to Bitcoin. Peter Shor, came up with this algorithm for factoring numbers kind of high level or solving the discrete logarithm problem, which is effectively what underlies Bitcoin's cryptography, namely ECDSA. And just to give you a sense of kind of how good versus a classical computer Shor's algorithm is, the chart on the left shows effectively the resources and the time required for a classical computer to solve the ECDLP for ECDSA, and the blue line is the quantum computer. So the red line is classical, blue line is quantum. So obviously the blue line is a lot better, and arguably, whereas the red line is completely intractable, the blue line is something that maybe would be tractable in a human scale time frame. Okay, so it breaks ECDSA. Shor's algorithm breaks ECDSA, and specifically, how is that relevant here? I like to think of blockchains and Bitcoin as having two key features compared to a traditional financial system. One is permissionlessness, right? So, the ability to directly interact with the system without needing the permission of anyone. And I kind of ascribe that property to the, like decentralized consensus, right? So decentralized consensus, miners, there's no one owner of this database, this UTXO set. And so, as a result, we have this permissionless property. And self-sovereignty. Self-sovereignty is what really the cryptography guarantees, and specifically the digital signatures, right? Because that is what, by producing a signature, that is the only authorization mechanism that I need in order to be able to spend. So permissionlessness, for anyone who pays attention to anything other than Bitcoin, there's many blockchains out there, and I think the difference between them, you could argue more or less, is along the spectrum of what is and what is not permissionless. But self-sovereignty is the thing that ties them all together. Without a cryptographic authorization mechanism that directly basically translates to spending or spend authorization, I don't think you have anything that's very different from a bank. And this is exactly, though, what a quantum computer breaks. So how does it break it? Okay, so like I said, Bitcoin uses digital signatures for authentication. And the upshot is that the secret key that I have in my secret public key pair is what enables me to generate a signature that corresponds to the public key. Only I should be able to produce that signature. So here on the right is just an example of a simple Bitcoin P2PKH transaction. And so you can see in there that the signature and the public key are both published as part of that transaction. So this in cryptography, this property of only being able to go one way, so I can compute a function with a secret key that basically requires only my knowledge of the secret key. This concept is called a trapdoor function, right? So with only knowledge of the public key, maybe stated inversely, with only knowledge of the public key, I should not be able to go backwards and compute the secret key, right? Because then that would then enable me, in the context of Bitcoin, to sign a message on your behalf, right? And so effectively what a quantum computer does using Shor's algorithm is break this trapdoor, right? And I think the philosophical conundrum that this presents here is, in a world where an entity with a quantum computer can reverse this trapdoor and produce signatures for really anyone with an exposed public key, what does it mean to own Bitcoin or any digital asset that's cryptographically secured, right? So, problem, okay. What follows is the question that everyone always has about this topic, which is, all right, we all know about Shor's algorithm. Thanks for telling me what I already know. When do I need to start caring about this? And then my primary caveat is as follows. This is one of my favorite quotes regarding science, right? So all models are wrong, some are useful. What I'm about to present is my personal model for how to consider quantum computers generally and how they're developing. There are others, and I encourage everyone who's interested in this topic to kind of explore some of those others. But hopefully this model that I use will prove at least somewhat instructive to you all. Okay, the way there's kind of two framings that I like to think about when considering what quantum computers are. First off, maybe it's worth noting that a quantum computer, like a classical computer, is an abstract concept, right? A classical computer can actually be implemented in a number of ways. It just so happens that the phones in our pocket or the laptops that some of you have open, we use effectively silicon-based semiconductors to implement these computers, but it doesn't necessarily have to be that way. And it's the same with quantum computers. Quantum computers can be realized in any number of different ways. In fact, there's probably a dozen approaches, and we'll talk about some of that a little bit more later. But sometimes it's easier, instead of thinking about the different ways that you could implement this computer, I like to think about it in terms of a stack of kind of what the computer, a cryptographically relevant quantum computer is comprised of. So maybe starting from the bottom, it's the actual physical layer, right? It's the physical layer, like what is the qubit? How are we realizing the qubit? Okay, and many people who follow this topic would probably at this point interject, hey, physical qubits are unable to run Shor's algorithm on their own. Why? Because they are noisy or they're fragile, and so you have to apply some additional step to the physical qubits to make them logical qubits, and therefore enable actual computation. By the way, there's a typo on the slide, as you've noticed. There's two control and integration layers. The second layer should say error correcting layer, right? Because that's exactly what I was just mentioning. You apply some error correction to the physical qubits, and then you have what are called logical qubits. And this logical qubit is the basic element or unit of computation with regards to a cryptographically relevant computer. But the third thing that's actually mentioned twice here is the control and integration layer. So it's not enough to just create one logical qubit. You have to create many logical qubits. And how many? Well, that's all determined by the algorithm layer. But ultimately, however many you need, you have to basically be able to connect these things together and control them in such a way that you can get a useful result. So this is a control and integration layer, sort of what I consider as the third layer of the stack. And then the algorithm layer that I mentioned a second ago, it's Shor's algorithm, but there are variants of Shor's algorithm that exploit this concept of a time-space trade-off. So if I have a bigger quantum computer with more logical qubits, I could potentially have, it's a different requirement, in terms of the size or time required, than if I have a small computer that I intend to run for some time. Okay, I'm not going to run through all these. These are 5 of the, in my opinion, most promising modalities for a quantum computer. I'm going to separate these into what I consider 3 generations that I think you need to kind of understand. Superconducting qubits are what Google and IBM effectively have built in their architectures. I consider this Gen 1. This was basically the first quantum computers were this. They run at high clock speeds, and they have demonstrated what's called below threshold error correction. The challenge is they are very difficult to scale. Raise your hand if you know what a quantum computer looks like, if you ever Googled it. Yeah, it's like a chandelier, right? So the chandeliers out there that you see, are roughly 100 to 1,000 qubits, right? So some of the estimates that we'll get into later have Shor's algorithm requiring, potentially 10,000 or even hundreds of thousands or millions of qubits, right? So a challenge with the superconducting Gen 1 architectures is how do you get all these chandeliers plugged into together? By the way, the chandelier thing actually has nothing to do with the quantum computer itself. It is the dilution refrigerator that brings the superconducting qubits down to like a nanokelvin. So that's Gen 1, so hard to scale, but relatively well understood and tested. What I consider Gen 2 quantum architectures are trapped ions and neutral atoms, which are the second 2 rows in this slide. These are, broadly speaking, much more stable qubits, right? So these qubits are a little bit easier to maintain. Their main trade-off is that they run more slowly, right? So, talking, kind of millisecond to even hundreds of milliseconds regimes. So even though you have a little bit more of a stable platform that you could potentially scale, the speed at which the cycle runs, potentially prevents this from being cryptographically relevant, at least on a human time span. And those are, Ion. There's these new approaches. There's startups that are built around them specifically. IonQ is the biggest trapped ion company, and then there's a new company, Oratomic, building a neutral atom machine. Quera is building a neutral atom machine, and Google actually also announced they're starting a neutral atom effort. The final two are kind of what I consider the most exotic forms of quantum computing. It's the silicon spins and photonics, right? So silicon spins at a very high level is sort of like the neutral atom, but it uses some kind of electron vacancy in a silicon atom to create a quantum computer. And why is that good? Well, potentially you could use the existing CMOS architecture that's already used to fabricate semiconductors to basically fab, millions or tens of millions of qubits at a time, right? So potentially, once you solve the fundamental physics problems, you can scale this very rapidly. Photonics uses photons, as kind of the name implies, to create a quantum computer, and both of these last two have the advantage that they potentially are very stable and they can run at very high clock speeds. And if you solve, like I said, the physics problems, you can kind of go from 0 to CRQC very quickly. Okay. Cool. So layer 2, error correction, right? So this is just a picture here of a surface code. A surface code is a way of arranging physical qubits to basically give you the required redundancy against errors in order to actually generate a logical qubit. So the way these codes work is effectively you need to define what error rate you need to logically hit. That error rate depends on how long your circuit is, right? And then you can effectively create these codes and size them accordingly to what you need to achieve, right? And so an important note here, and actually, a milestone a couple of years ago that I think really kicked off the current progress, or that exemplifies the current state of progress of quantum is Google, through its Willow processor, demonstrated what's called below threshold error correction. It's very important. What that is basically as you add physical qubits and make this shape bigger and bigger, the error rate, the logical error rate, decreases exponentially, right? Before that demonstration, or without below threshold demonstration, what you have is a situation in which every marginal additional qubit that you're adding to the shape is basically adding errors at an ever-increasing rate, and it's running away from you, right? So this is why below threshold is a very important concept, and this is why Google's result from 2024 was really critical in the context of quantum computing. Just to give you a sense on really what I think the story has been about quantum computing development in the last 2 years has really been around this error correction, right? Because you can imagine, this is all great. We got squares of qubits, but you can kind of just see this is like you have a quadratic function here, right? As this, as you want more and more fidelity, you need to square effectively, the size of your little patch. Newer families of codes, known as QLDPC codes, drastically reduce the required size of your actual physical system. So this has really been, I would say, the dominant effort in the last 2 years in terms of scaling a quantum computer. And in fact, we're going to talk about some of the papers that came out a couple weeks ago later. But the Oratomic paper, the headline is Shor's algorithm is possible on ECDSA with as few as 10,000 physical qubits. That is almost entirely because they apply QLDPC codes in place of surface codes. So this is an area to really watch. Okay, on the control layer, this diagram here is basically showing what a logical tick, so one unit of quantum computing time looks like, right? So the important thing to take away from this slide is that there's a classical quantum interface, right? So you need to be able to control this quantum computer, and we are all beings governed by classical physics, given that the scale that we exist in. And so we need some way to be able to control the system that is classical, but it needs to be able to interface with this fragile quantum world without breaking it, right? And so you basically need a way to use, you need to measure effectively something, some part of this without destroying any of the fragile quantum states that it's in. And you need to be able to do that, determine what errors have occurred, and then you need to correct for those errors and feed those back into the overall system, right? And the rate at which this all happens, this happens at every single step of any quantum circuit. The rate at which this happens is really your clock speed. Cool, and this is just sorry, it's a little blurry. This is from one of the orthogonal papers. This just kind of just shows you, this is a simplified diagram of what control looks like. In practice, these are computers, right? So we need the various parts of a computer that you would expect to have, some kind of short-term memory, some RAM, effectively, maybe storage, a processor, et cetera, and then all of those have to work in sequence in order for Shor's algorithm to ultimately, or Shor's algorithm or any quantum algorithm to compute anything useful. Okay, great. So with that foundation now laid, this is how I think about how we can basically quantitatively measure progress towards Q-Day. So the first 3 layers of the stack, the physical layer, the error correction layer, the control layer, effectively define what I consider the supply side. So what does my quantum, how powerful is my quantum computer? What can it do, right? And the relevant metrics here are logical qubit capacity. So this is basically the number of logical qubits that I have that are error corrected, that I have to work with at any one step of my algorithm. The next is my logical operations budget. And that is basically, I've created these logical qubits targeting a given error rate. And with each step in my computation, there's a chance for an error based on that error rate that I've targeted. So basically, the number of steps that I can go without the whole thing falling over is what I call the logical operations budget. The last piece is your quantum operations throughput. So this is basically like in each human wall clock time, how many quantum operations or how many steps in the circuit can I take per second? Okay, so that's the supply side. The demand side is basically all the variants of Shor's algorithm, or all the different ways that you could possibly think to do it. This sets what you need to hit, right? So basically, this is the goalpost for being considered cryptographically relevant, right? So I have a minimum circuit width that my LQC has to exceed. I have a number of overall operations, a circuit depth that my logical operations budget has to exceed, and that depth is basically, I have a logical error rate that I would need to hit in order to make that depth, and then ultimately this to be cryptographically relevant to us people, this has to run in some human timescale, right? Okay. Yep, and I just said this. Okay, so this is a kind of how I illustrate this in a picture. Okay, so again, LQC is I guess in this picture, it's the height of the rectangle, right? So the number, the width of the capacity of my system. The depth or the length of this rectangle is how far, basically how far I need to run. I have this kind of gradient here to illustrate that, you can keep running this thing and running this thing, but eventually, like I said, at some point, you just lose coherence and the system falls over, and you need to make sure that whatever you're targeting is on the left side of that, right? So you need to make sure you get a meaningful result at the end. And then the speed at which you can run down this rectangle is, again, the QOT. Okay, this is from the Google paper that was published 3 weeks ago, the famous Google paper. And this is a resource estimate, right? So this resource estimate is really kind of about how big is this rectangle? And that's what this is, okay? So this resource estimate, you can see on the x-axis here is to Foley gates. This is the LOB. This is your depth, basically, of your critical path. On the y-axis is your logical qubits. This is the width that you need to hit. And you can see there's a bunch of prior works here in blue, which is effectively people have tried to solve, assume different architectures and see where they land on the trade-off space. And the reason this Google paper was significant, you can just kind of see from the picture, is you had basically a sufficient frontier where you could have, lots of logical qubits and maybe run it fast, or you could have very few logical qubits and maybe run it slow or have lots of operations. And the Google paper kind of pushed that way, way back. How did it do it? It did it by targeting specifically ECDSA. And this is, I think, one important thing I want to make sure everyone takes away from this talk. For whatever reason, the study of Shor's algorithm in the physics community has focused on RSA. RSA is a legacy public key system, public key crypto system that I don't think anyone in blockchain uses at all. Everyone uses ECDSA for its performance characteristics. However, Shor's algorithm runs in time logarithmic to the key, or polylogarithmic to the key length. And so RSA 2048 has 2048-bit keys. ECDSA has 256-bit keys, right? And so this is actually a relatively recently studied, ECDSA is only being relatively recently studied in the physics community, and that is largely what has driven, basically the moving of the efficient frontier back through the Google work. Cool, okay. The other important thing about the Google work is it actually demonstrated for the first time the potential that the QOT, the quantum, your quantum operations throughput or your speed, your clock speed, might be relevant not only to threaten effectively lost keys or static keys with exposed public keys, but potentially run fast enough. You could theoretically run the circuit that I showed a second ago fast enough to fit inside of a Bitcoin block time, right? So this is another chart from that paper. And effectively, the attack would be if you had a quantum computer of scale that the Google paper references, what you could do is basically front run any transaction in the mempool, pay a fee that was higher than whoever was the sender paid, and then you could obviously send that, that transaction would go to whatever address you specified, and now you'd be able to threaten every single transaction or every single UTXO on the Bitcoin blockchain were it to ever move. So that was I think another interesting thing, and we'll talk a little bit more about the various speeds of these systems in a minute. Cool. So distilling all this down, I think this is maybe a chart that I would like you guys to take away is like, what do you have to do to get to a cryptographically relevant quantum computer? So I've given you all the foundations. I've kind of shown how they all fit together and how to think about the algorithm and how a CRQC, what a CRQC has to do effectively to be a CRQC. Okay, so what do you have to do? First, you have to demonstrate exponential suppression. Okay, and this is really per kind of regime, right? So just because Google demonstrated below threshold exponential air suppression doesn't mean that or Atomic or IBM has, right? So I think each system basically has to demonstrate exponential suppression. Then you need to be able to show that not only you can create a qubit, you need to continuously operate it for a given time. You need to then scale the number of logical qubits to the required width. And then lastly, you need to be able to make them last for as long as your circuit requires. So I've just spent 20 minutes giving you the stack-based overview of quantum computing. I'm not going to spend long talking about this, but I talked about the different physical modalities. And I think the point that I want to make with this slide is that each physical modality is kind of its own tech tree. So you can't really think of like, I don't want to go all the way back to my stack paper. You can't really think of like, oh, I can use surface codes and neutral atoms and I can make something. Like it kind of doesn't work like that. You can technically, but really in practice, each quantum computing company is taking a very vertically integrated approach towards solving this problem. And this is roughly speaking where everything is today. I mentioned the Gen 1 superconducting. They've demonstrated, and I mentioned this all already, below threshold's been demonstrated. They run fast, but they're kind of hard to scale. Neutral atoms ions run slow, but they're more stable. And people are hopeful that they can scale versus these other ones, silicon spins and photons. Nothing's really been demonstrated, but if they were to work, then theoretically they would solve everyone's problems. Cool. And so yeah, again, what do you need to do to get to a CRQC? So we're here. By the way, this is a good time to point out. There is no CRQC today. No quantum computer in existence can threaten Bitcoin or any other cryptographic system. We're kind of here in this yellow box. Ultimately, we need to figure out how to scale or continuously run a single logical qubit. Then we need to figure out how to get the required width. Then we need to be able to run the requisite depth. So basically, this is like kind of a quick down and dirty way to find out if you're long or short quantum. If you think the hard part of quantum computing or the scientific endeavor is to demonstrate below threshold error correction and get a continuously operating logical qubit, you should be bullish because you've kind of already done 75 to 80% of the blue box. If you think that the actual hard part is plugging all these things together and controlling this system and scaling it, then you might be bearish. And that's kind of a quick way you can kind of tell. Okay, in the last 2 minutes here, I'm going to give just a quick way how to think about where people are at with different Q-day forecasts. Survey of experts, broadly speaking, 10 to 15 years is the timeline when the majority of experts assume that Q-day will happen. Quantum computing companies have a whole bunch of forecasts around their physical qubits, the logical error rate that they're targeting, and the the number of logical qubits they'll have given the surface or the error codes they're using. Obviously, Google has some work that pushed the requirements lower, as did Atomic, which was the other major paper, came out of Caltech. And here's a couple of just recent milestones. I pulled this slide up because I want people to understand that even though the Google and Caltech papers were resource estimates and they kind of applied theoretical optimizations to make the problem smaller, it does not mean that there has not been progress on the hardware side as well. Cool, and then this is a model that we run. This is just a napkin math model, which is like, hey, where are we at in terms of physical qubits, physical qubit fidelity, interconnection complexity, surface code, or code efficiency, et cetera, and you just kind of napkin math some growth rates on that. we've got a model that kind of shows this number. So with some different assumptions, you can get between 2029 and 2042. In short, I think relevant to Bitcoin, especially in light of this recent work that's come from Google and or Atomic. Again, no quantum computer exists today. But the last thing in conclusion I want to leave you guys with is some relevant questions. This is kind of how a lot of people like to think about this. Are we solving a physics problem? Are we solving an engineering problem? I think the question everyone needs to ask as we're watching this space develop is, how will resource estimates evolve over time? And then how quickly do we think that hardware might progress? How long will it take to select, test, implement post-quantum cryptography, and then ultimately migrate, right? And so I think hopefully what this, if anything, this presentation has hopefully left you with more questions than answers, and that is the right position because there's a lot of uncertainty. We don't know a lot of the, the progress, the pace of progress. We don't know what unknown obstacles may emerge in the path of scaling a CRQC. We don't know if there will be some come-from-behind approach that brings us to Q-Day much, much sooner. I think what we do know is there's a potential existential risk to Bitcoin, and what we don't want to do is overshoot it. So I like this way of thinking about it. You can kind of basically layer on what you think your timeline to Q-Day is with your timeline to basically fixing Bitcoin, and then you just have to kind of plug in your own assumptions, and what you don't want is some kind of intersection, right? Ideally, like the blue bar is the time it takes to fix Bitcoin, and the orange bar is like when a CRQC might hit, and you don't want those things to intersect. So I think ultimately this calls for a conservative approach or a conservative attitude around how things might evolve. In other words, assuming things might evolve faster than we hope they do, and therefore to prioritize Bitcoin's migration to post-quantum cryptography, which will be the topic, I think, will be a topic of one of the next talks. So with that, I don't think I have time for questions, but I really appreciate all of your attention, and come find me after if you have questions about this presentation. Thank you.
Who in the world is mining Bitcoin in Australia right now? I mean,
I don't like a company going bankrupt, but whenever something like this happens, you can go into Pacer, find the court filings, and then you have all of this juicy open source information about who is involved in these things. Some of the names that have surfaced from this, there's some really weird stuff in here. Like, for instance, is the Chicago Blackhawks hockey team? This is real for $1.26 million.
At first blush, might be like, well, yeah, of course, just, check the boxes. But if
Just log the trade, bro.
Yeah, just log the trade. That's not how it works.
Now, this is very much a he said, she said story.
Riddled with drama.
All righty, y'all. For our next talk, we have Jonas Nick on to talk about op, check, shrink.
All right. Does this work? Oh, yeah, my slides. Perfect. Good day, everyone. Hello. So, as of today, there's no concrete proposal for post-quantum signature verification in Bitcoin. Over the last year, our team at Blockstream Research, we have been looking into this, and today I'm going to share what we've learned, why hash-based signatures are a pragmatic choice for post-quantum Bitcoin in the relatively near term. We walk through shrinks and shrimps step by step. It's currently the smallest post-quantum signature scheme that does not rely on exotic assumptions or exotic constructions. And finally, since this is up next, we're going to look at what a concrete proposal could look like. So today, modern Bitcoin outputs lock funds to a Schnorr key, and to spend them, you provide a Schnorr signature. Of course, as we know, Schnorr signatures, they are vulnerable to quantum computers. And the most natural way to add post-quantum security is by adding a PQ option to the taproot tree. After a soft fork, an output can commit to both a Schnorr key and a PQ key. And because the tree only requires revealing the path you execute, you can continue spending with cheap Schnorr signatures, and the transaction cost is basically unchanged. The post-quantum option is there, but it's just sitting dormant. And only when a cryptographically relevant quantum computer appears, you do use that second path. You spend using the post-quantum signature, and only then do you pay the transaction cost of the PQ option. Before we look at specific post-quantum schemes, let's be clear about what we're trying to avoid. Adding post-quantum signature verification can go wrong in several ways. First, throughput collapses. If the signatures are simply too large, Blockspace fills up, and many users won't be able to transact at all, which reduces the usefulness of Bitcoin. Verification costs. If the computational requirements are too high, there will be less full node verification, which impacts decentralization. Signing costs. We have to ensure that hardware wallets and constrained devices can actually still sign in a reasonable time. Cryptography breaks because it's built on assumptions that don't hold up over time. Nobody adopts the proposal because it's too complex or doesn't integrate with existing infrastructure. If it's only you who adopts a proposal, that is not enough. If the rest of the network gets compromised, your perfectly secure coins become worthless. The implementation ends up containing bugs or being vulnerable against attacks, as someone has to maintain this code in Bitcoin's consensus rules basically forever without introducing even the slightest incompatibilities between versions. A proposal that avoids these pitfalls has the highest chance of obtaining rough consensus. So let's start by looking at the standard candidates, namely schemes standardized by NIST. They exist today. They have working implementations, and relatively little additional effort would be needed to create a Bitcoin improvement proposal. Our baseline is the Schnorr signature scheme as used in Taproot. If every transaction used it consistently, Bitcoin could support 6.5 transactions per second, assuming the current average transaction shape. Schnorr signatures support features that current wallet infrastructure relies on, in particular BIP32, unhardened key derivation. And they also enable efficiency upgrades we've seen adopted in the past years, like music, as well as planned privacy and efficiency improvements like threshold signatures, silent payments, cross-input signature aggregation. NIST standardized MLDSA, which is based on lattice assumptions. Here, throughput would collapse to about half a transaction per second, and we lose all of the advanced features, including BIP32 and hardened derivation. Also standardized is SLHDSA. The scheme is based on hash functions, which is great because they are conservative assumptions and assumptions that we already trust in Bitcoin. However, throughput drops even further to 0.36 transactions per second, and again, there are no features. And the takeaway here is that these signature schemes, they are not drop-in solutions. Network throughput gets decimated. One could argue that a block size increase can fix the throughput problem, but if we want a timely, pragmatic upgrade, then we should not bundle it with a highly controversial block size increase proposal. Might be a valid consideration for the future, but here we're focusing on cryptographic solutions for now. We've looked at standard schemes that will be relatively easy to deploy today, but they come with hard-to-swallow trade-offs. Now let's look at schemes that have the potential of better trade-offs, but they require significantly more research. Take Falcon WS, for example. It's a very new scheme. It has just been published. It offers significantly better signature sizes, but it's entirely too early to consider for deployment. I just put it on the slide to illustrate what might be eventually possible with lattice-based signatures. Then there are lattice-based schemes that support features we actually want, like unhardened BIP32 or threshold signature and more. There's a very interesting direction for further research, but unfortunately, the moment you add those features, the signature sizes increase significantly compared to lattice-based signatures that don't have these features. Then there is SkiSign. based on isogenies. Sizes are very good, and isogenies have the potential to support advanced features. But the catch are the cryptographic assumptions. They are very immature compared to, for example, lattices. There's a real risk that they could break, and the risk won't disappear anytime soon. Building confidence in new cryptographic assumptions takes many years. And finally, there's the approach of having a single succinct proof, a snark that aggregates all individual signatures in a block. This is promising for throughput. It's been called BitZip in the Bitcoin space, LeanVM in Ethereum. But the engineering complexity is quite massive. Who actually will compute the proof? How does this not lead to mining centralization? And what effects does it have on the peer-to-peer network? The bottom line is that all these are promising directions for the future, but not something that would be ready today. So as we've seen, we've been trying to navigating this multi-dimensional trade-off space, assumptions, efficiency, features, and complexity. But there are two distinct directions that look highly promising for hash-based signatures. First, we can add a completely new dimension, statefulness, which opens up a new design space. And second, we can make a trade-off. We accept a minor increase in protocol complexity in exchange for a significant efficiency gain. These two directions make hash-based signatures a very attractive candidate, and we achieve much better efficiency without introducing new cryptographic assumptions, and the cryptography remains relatively easy to explain and implement. So to understand how we can make use of the statefulness dimension, we have to look at a concept that is inherent in hash-based signatures, the signature budget. Every hash-based signature scheme comes with a parameter that dictates exactly how many times a single key can securely sign a message. In SLHDSA, the budget is set to 2 to the 64, which is pretty much unlimited for practical purposes. And this brings us to the fundamental mechanic we're taking advantage of. If you deliberately shrink the signature budget, the size of the signature shrinks along with it. Smaller budget equals smaller signature. However, if you accidentally exceed that budget, the security breaks down. With SLHDSA signature budget of 2 to the 64, the signature size is nearly 8 kilobytes and throughput is 0.36 transactions per second. But what happens if we reduce the budget? Let's pick 2 to the 40, which is about 1 trillion signatures per key. This is more than enough. There's not enough space in thousands of years of Bitcoin blocks for 1 trillion signatures. Signature size drops to 5.7 kilobytes, improving throughput by about 33%. So how low can we push the signature budget? In Bitcoin, best practice says that we don't reuse addresses. On layer 1, key is typically used to sign only once or maybe a few times. This means theoretically our budget can be very small. But what happens if a user needs to exceed it for whatever reason? We give them a fallback option. We create a signing structure with 1 public key but 2 signing paths. You use the compact path to get small signatures as long as you stay within the budget. And if you exceed it, you simply fall back to a larger signature. The fallback is always available. But there's an issue now. To safely use the compact path, the signer must perfectly track how many times they have signed to not exceed the signature budget of the compact instance. This counter is state that must be persisted and never reset across reboots. Because of this, we say the scheme is stateful. And statefulness is unfortunately not applicable in certain scenarios, for example, desktop or mobile wallets. Let's walk through a standard failure scenario. User signs a transaction and their state updates to one signature out of a signature budget of, let's say, 3. Then the user backs up their disk. Then they sign another transaction. The state updates to 2 out of 3. Now suddenly something happens, hardware dies, and they need to restore from that backup. So the wallet reverts to the old state, 1 out of 3. And next time they sign, state 1 is reused and their coins are compromised. And for that reason, when we first explored this direction, I thought it's a really neat trick, but not really practical, because it violates a fundamental property of Bitcoin's cryptographic design, which is misuse resistance. We spent a massive amount of effort ensuring that users and developers cannot accidentally mess up. But a stateful scheme is inherently more fragile than a stateless one. So here's one setup where the user cannot mess up. So a user has a dedicated signing device. On initialization, the device generates the seed and sets the initial state. The state lives exclusively on that device and never leaves it. The device can produce compact signatures. And as a nice additional safety mechanism, the state is public. So the software wallet can independently verify that a signature does not reuse state before anything is sent to the network. What happens if the device breaks, it's lost, or the user wants to use a different device? The user loads the seed into the new device, and the new device automatically uses the stateless fallback path that produces a larger signature. This setup works because by taking the state completely out of the hands of the user, they have no ability to corrupt it. Now that we've seen how it's possible to manage state safely, let's put a name to this signature scheme. We call it Shrinks. It combines 2 ideas. First, 2 signing paths under a single public key, a compact stateful path and a stateless fallback. And second, a particularly efficient compact path, which is not something we have time to look at today, but it's relatively straightforward to explain. Let's compare the throughput of Shrinks. So as a reminder, standard SLH DSA gives 0.36 transactions per second, and changing the signing budget to 2 to the 40 results in 0.48 transactions per second. And with Shrinks, the compact path produces a signature of just 580 bytes. If every user was always able to use the compact path of Shrinks and never had to use the fallback, the throughput would be 3 transactions per second. So what Shrinks achieves is a fundamental shift in how risk is handled. Instead of systemic risks that affect every user on the network, low throughput, questionable crypto assumptions, fragile consensus protocol, Shrinks converts that into localized risk, state management on individual devices. And localized risk can be managed. Shrimps extends Shrinks using a simple observation. With Shrinks, the scheme we've seen before, you have a compact and a fallback path. If your primary device fails, you load your seed into a new device, you need to use the large stateless fallback. But how often do you need to initialize a new device? In practice, we can put an upper bound on how many times a seed gets loaded into a new device. No more than 1,000 times per key, for example, or over the lifetime of a wallet. With that observation, we can introduce a second compact path specifically for these backup devices that result in signatures of about 3,000 bytes, 5 times larger than a signature from the primary device. Shrimp signatures created by backup devices are about 2.5 times smaller than an SLH DSA fallback, and in throughput terms, that gives us about 0.87 transactions per second. So far, we've covered the first direction of the talk, using statefulness to create small primary signatures. But now let's look at the second direction. How far can we optimize the fallback path itself? And again, first row in the table represents SLH DSA. The second row, the same scheme, signing budget reduced to 2 to the 40. But we can go further. Since SLH DSA was standardized, several optimizations to the underlying Sphinx Plus scheme have been published. By using optimizations that are called WATS plus C and PORS plus FP, we can drop to 5,060 bytes, a 13% improvement. And there's no performance penalty. The only downside is that we deviate from the NIST standard. Next, if we additionally accept that signing and key generation take 5 times longer, we can squeeze out another 10% improvement in size. And if we allow verification time to increase to roughly 1.5 times that of Schnorr per byte, we get another 15% improvement. So this table shows that by making calculated trade-offs, we can cut the size of a stateless hash-based signature scheme in half. And if we only cared about size, we can turn these dials even further to reduce the size more. So here's one possible proposal to demonstrate how we could combine everything we've seen today. Proposal is built on 2 design principles. First, we do not increase verification time compared to SLH DSA. This avoids making future block size increases harder. And moreover, should block-wide signature aggregation via snarks ever be adopted, maintaining fast verification significantly simplifies the proving process. And second, we abandon the idea of a one-size-fits-all signature. Instead, we introduce multiple signature schemes that are tailored for specific use cases. So first, we have desktop and mobile layer 1 wallets. As we've seen, they cannot safely keep state. But they are typically running on fast CPUs, so they could more easily handle a slow, size-optimized signing scheme. A signing budget of 2 to the 40 would never be hit accidentally. Then we have dedicated signing devices. As we've seen, we want them to keep state securely, but often hardware wallets have weak processors. So here we use a scheme that has fast signing and rely on shrinks and shrimps to reduce signature size. We drop the stateless fallback to a budget of 2 to the 32 because no human being is ever going to physically push a button on a hardware wallet 4 billion times to sign with a fallback path. And finally, the proposal considers Lightning nodes. Lightning is stateful by construction and benefits from fast signing. We give them the same 2 to the 32 budget because if a node actually ever reaches 4 billion signatures, they can simply roll over to a new key. And even more importantly, it should be possible for Lightning nodes to leverage the compact shrinks path when closing channels cooperatively. So the result of this analysis will be 4 specialized signature variants working together. Using this mix, the effective throughput now ranges anywhere between 0.6 to 3 transactions per second, way beyond the 0.36 baseline of standard SLH DSA. The toy proposal comes with specific downsides, and it also raises several questions. Proposal is not size optimized because it prioritizes verification time. The verification cost per byte in this proposal is no more than 6 times smaller than Schnorr, and therefore block size theoretically could be increased by a factor of 6 without increasing block verification time. But we need better benchmarks for making this a more rigorous argument. Giving the option of combining multiple signature schemes instead of just having a single one reduces fungibility and privacy. Which use cases are not covered by this proposal? How does it interact with layer 2 protocols exactly? How should these signature schemes be designed so they are ready for SNARK-based aggregation in a potential future soft fork, or should this even be a consideration? How much signing time is tolerable on different platforms? If longer signing times are not an issue, signature sizes can be reduced significantly. We need better benchmarks for signing on multiple different hardware platforms. And finally, how should a reference implementation look like? Is it just C++ or a formal specification? We're changing the cryptography potentially of the Bitcoin network here. In the age of LLMs, formal verification of consensus critical code is more feasible than it has ever been. Okay, we're coming to an end. We covered a lot of material today, and there's a real danger here because the design space for post-quantum cryptography is just very large, and there's no single best answer. It's very easy to fall into some sort of analysis paralysis. But the summary is that optimized stateful hash-based signatures can offer better trade-offs than the standard schemes that are available today. And there's even an argument to be made that stateful signatures are a somewhat conservative design because it may allow Bitcoin to operate in a post-quantum world using only this signature scheme without having to bet on specific future soft forks. At the same time, research into longer-term improvements like better lattice-based schemes, aggregation, isogeny crypto should continue in parallel. The space of useful stateful optimizations to hash-based signature schemes is probably not exhaustively searched so far. So what other optimizations exist beyond shrinks and shrimps? How can careful engineering guarantee the safety of stateful setups? And can layer 2 protocols directly leverage stateful signatures? So finally, here are links to our paper, Hash-Based Signatures for Bitcoin. This paper provides an intro to hash-based signatures and their parameters, and the scripts I used to generate the numbers in this talk, they are online. We have a C++ and a simplicity implementation of shrinks, and for anyone interested to explore shrinks on a live network, the simplicity implementation can be used on Liquid in production today. I think I'm out of time, so we don't have time for questions, unfortunately, but feel free to reach out to me anytime online or here.
Alrighty, y'all. For our next talk, we have Rob and Linus on to talk about transaction introspection without a soft fork.
Hi, everyone. Well, actually, I'm not talking about binary hash and transaction introspection. I wanted to do that, but I already did it at MIT this weekend. If you are curious about it, go to my Twitter. I shared the talk there. What I'm going to talk about is payments maximalism. So now that all the quantum doomers are gone, we're going to talk about store of value dooming. So crypto changed a bit, like Bitcoin, the Bitcoin culture changed a bit over the years. Maybe you have noticed, I hope you have noticed. It kind of raises the question, are we actually building a cypherpunk revolution, or are we just LARPing? And I think we should talk about that. I don't have a solution for that. I don't even know if we can build a cypherpunk revolution, but I think we should talk about that topic. And the key message of my talk is that we should talk about this complex of questions. First of all, what is Bitcoin? Satoshi's original vision. Satoshi's vision is already a very inflammatory word that we should not talk about. But I think we should talk about it because it's so inflammatory. So what is Bitcoin? Well, let's read the white paper. It's electronic cash. Electronic cash and payments. So that seems to be what the original vision was about, electronic cash and payments. But, oh yeah, and Satoshi, in his second email already, he talked about scaling Bitcoin to 100 million transactions per day and to like compete with Visa. So that seems to be what Bitcoin is actually, was originally about. So he said scaling to 100 million transactions per day. Currently, we're doing like 500,000 transactions, which is a couple of orders of magnitude off. In the meanwhile, Visa scaled way more, it got way more adopted, and now they are processing even like 500 million transactions per day, and we are still at 500,000. So we are basically a couple of orders of magnitude off here, which is a bit unfortunate, if you ask me. And I think it's even worse. I want to make the case that store of value isn't enough, because if Bitcoin is not used as money, then it won't be valued. It might fail if Bitcoin is not used for payments. And it's not even me thinking that. Satoshi said the same. He basically said, we cannot even have that store of value thing. We cannot have 21 million coins if we don't have lots of transactions. He said, in 20 years, like 2030, there will be either a lot of transactions or none at all. Maybe things have changed, but he definitely was convinced that this is the case. Basically, we cannot have store of value without lots of transactions, without Bitcoin being used for payments. And other people agree, even Jack Dorsey, the founder of Twitter and like Square, and like he might know about payments, and his opinion is basically the same as Satoshi's, that Bitcoin will fail if we are not using it for everyday payments. They might be wrong, but I think it's important to notice these opinions. Why is that the case? What is like the argument? What are the arguments why Bitcoin might fail if it's only a store of value? Well, first of all, the transaction fees are supposed to become the main compensation for miners, and we have that death spiral. Like if we have only a few transactions, then there are only a little fees to pay the miners, and that leads to low security, and low security leads to no value. I guess you guys have heard of that. So basically from that follows either we have lots of transactions, or we need to compromise on fundamental properties of Bitcoin. And some of them, like, either we can have high fees. If everyone would pay like $100 fees or something, we can have at the current transaction rate the same security budget. But I guess most of you are not willing to pay $100 per transaction. The other thing is we could just reduce the security. Like if we're not paying miners enough, the hash rate will go down and there will be less security. I'm not sure if that is a thing that we would like to see. Or we could break the 21 million cap. We can just introduce long tail emission and keep on like creating new coins, but that of course will also harm the store of value use case. And the other thing is we just introduce taxing. And of course all of you like taxes, so I guess you would be very happy if you get taxed on your Bitcoin. So basically we have that dilemma, either we have lots of transactions or we need to compromise on some fundamental property of Bitcoin. Also, is it even a store of value if you can't just freely spend it? It's quite an issue. Like if you can't spend your purchasing power, like if you need permission from some third party to spend your coins, if you need to go through an exchange, is it even Bitcoin? Is it permissionless? Is it peer-to-peer cash? I'm not sure. And also there's that issue that people are actually not, when they're using Bitcoin as a store of value, they're usually giving it to custodians. And the more we are giving our Bitcoins to Coinbase, the more centralized it gets, the more we risk that people create paper Bitcoin, that they're promising the same Bitcoin to multiple people. And that also harms the store of value case, and it also might harm price stability. Something similar actually happens to gold. It might be a conspiracy theory that there's lots of paper gold, but I feel like it's quite obvious. And the other thing is it might be uninspiring to some of the best developers. When I talk to some of the best developers, they are saying they are actually inspired to work on Bitcoin because Bitcoin is cypherpunk. They think payments or like peer-to-peer electronic cash is an exciting thing, but they are not super excited about store value. Yeah, and there is missing a slide, I think. So what actually is needed is payments. Like, we cannot just have store of value. If we only have store of value, we run into all kinds of issues, so we also need payments. But what is needed for, what do we need for payments? What do we need from Bitcoin to be successful as a payment system? First of all, we need scalability, because networks effect are super critical. You won't use the money that not other people are using. You will use the money that other people are using. And there's Metcalfe's law essentially saying the value of a network is basically the square of the number of its users. So the more users there are, the more the value goes up. And that is also good for the store of value case. And what you also need, you need to be able to transfer small amounts for low fees. Because if it's only for high amounts and large fees, then you will not use it for payments. Also, you need privacy. You only reveal what you want to reveal. It's kind of like also important for the store of value use case, because if you don't have privacy, then eventually people can just take it from you. And another very important thing that we should talk more about is usability of Bitcoin. Like, we need easy onboarding. It needs to be like frictionless. We need simple usability, and we need quick finality for Bitcoin to actually be usable for payments. A lot of these things are kind of getting addressed, but I think we should focus more on that. We really should put this into the focus of the community, not just number go up or stuff like that. This is the important part, I think. And of course, there's a lot of other things that are super complicated. You need stability, you need on and off ramps and so on. I'm not going to talk about this in this talk, but yeah, it needs a few more ingredients, but I think these are the key ingredients that we can actually work on. There's Lightning. Lightning is great because of instant finality. However, it has a lot of drawbacks. It has like this complexity, there's inbound liquidity, things that you have to manage your channels. Also, there is that centralization aspect of like LSPs providing liquidity to people. And all of that leads to lots of custodial solutions. Many people are using Lightning custodially, either via Wallet of Satoshi or like with eCash. Then there is Spark. Arguably, it's non-custodial, or at least that's what their marketing is. I would say it's pretty custodial. And the bigger problem is it doesn't contribute to the security budget. This is not on-chain transactions. They are not paying miners. They are paying the LSPs. So it's not solving one of the fundamental problems. And the other thing is, if the fees are too high, then the unilateral exit is expensive, and that means you cannot actually enforce your rights. So Lightning depends on small fees. And if you have like scalability solutions like channel factories, arcs, and timeout trees, it actually becomes worse, because here the exit is even more expensive. And one solution that I like a lot is shielded CSV. I think that can help us to at least get a lot better scalability and better privacy. It's a paper that I wrote with Jonas Nick and Liam Egan. I'm not going to talk too much about the details of how it works. There are a lot of talks about shielded CSV. If you are curious, check them out. What I'm going to point out are the key features. First of all, it scales quite well. It can scale Bitcoin from roughly 7 transactions per second to on the order of 120 transactions per second. And that is already the level of PayPal, roughly. It also gives you strong privacy. It makes blocks actually cheap to verify. Like a block full of CSV transactions is actually cheaper to verify than a regular Bitcoin block, which is a great feature for scaling further. You have nice things like reusable addresses, so I just post one address on Twitter or whatever, and everyone can pay me, and nobody can link payments. It doesn't bloat the UTXO set, so it's nice for fully validating nodes. And no soft fork is required. So we can build a version of that without soft forks, but actually soft forks would be better. Like if we had a native snark verifier, something like great script restoration or simplicity, that would allow us to reduce the trust assumption of the soft forkless version. And actually, Liam and I, we plan to create a foundation to like raise grants to build this protocol and roll it out on Bitcoin. But this is not enough. It's just 120 transactions per second. And now comes the heretic thing. Like, I like big blocks, and I cannot lie. I know you shouldn't say stuff like that at a Bitcoin conference, but I think we should talk about it. Like, if you are still like waking up at night in cold sweat, screaming like at Roger Ver or something, I think we should get over it. Huh? And also like this entire fake Toshi thing, like if fake Toshi says the sky is blue, we shouldn't say it's red just because he's a scammer. I think that's very, very important. A lot of people have this trauma from like the block size war that a lot of good ideas just got buried in like, it got tainted by bullshit. But it's still good ideas, even though it got tainted because people like fake Toshi talked about it. And it turns out there's actually smart people who propose bigger blocks. First of all, Satoshi did it. In his second email, he already talked about basically 700 megabyte blocks. It was his original intention to scale Bitcoin just by bigger blocks. So maybe there is something to it. TouchDryer proposed in a Lightning paper 112 megabyte blocks, which is quite surprising. A lot of people think Lightning is just a solution, but the Lightning paper says, no, it's not the solution. We also need a block size increase to make it a solution. Quite interesting. I think we should talk about that more. And even Peter Wöller, he introduced, he proposed BIP 103 back in the day, like it was 2015. I don't want to quote him too much on this. Like, I'm not sure if he's still championing a soft fork for that. Most likely not. But back then, he proposed increasing the block size with the rate of improvement of network speed and like hardware improvements, and which is estimated to be roughly 17% per year. And that would allow us to scale sheeted CSV basically to global scale. Like if we eventually grow blocks to 100 megabyte, we could scale to 3,500 transactions per second or even more. And that would give us Visa scale. So we could compete with Visa with just 100 megabyte blocks. And since sheeted CSV is so cheap to verify, like we basically just need blobs of arbitrary data instead of transactions, it's not harming decentralization as much as just naively increasing the block size. Of course, you might hate me for that, but I think it's worth thinking about increasing the block size eventually at some point. Another important thing is usability. Simplicity is key to adoption. Like, Bitcoin won't be used if it's not simple. If you think about like how Apple Pay and Google Pay works, they make it like just as easy as possible. Like just one click on your site and you can pay. And they spend like tons and tons of hours and like they have great UX engineers who just make it as frictionless as possible. And I think we should do the same. Also because all kinds of like unnecessary complexity triggers loss aversion. Like humans have that cognitive bias that they are more scared of a potential loss than a potential win. And that's why we kind of like, yeah, we are too risk averse in many things. And that is very fundamental to payments because like money is something that is necessary for survival from our primal brain points of view. And it fears dying essentially when something is too complex. So complexity is the absolute enemy of being successful as a payment system. And on the other hand, simplicity feels trustworthy. Our primal brain thinks something is more trustworthy when it's easy to understand. yeah, so we need intuitive UX, and we need to meet users' expectations. There's a really cool book called Insanely Simple, The Obsession That Drives Apple's Success. It might be over the top in some senses, but I think the key ideas of this book should be very much at the focus of the Bitcoin community to make Bitcoin payments so simple that they are actually being used by people. For example, how long does it take to onboard a user or a merchant? I know some people who go around and they try to onboard merchants, and they have like this long PDFs and stuff like that, and nobody's doing it. They are not reading it. It must be super simple. It must be just like one click and that's it. And we should really focus on how to make this better. What does it mean? Like, what does good UX actually mean? Well, one cool idea, like Peter Wöller said that, users shouldn't be exposed to any cryptographic material. You shouldn't show users public keys, private keys. All that stuff is for computers. It's not for humans. So basically, we should converge against something similar to Lightning addresses or like a Bitcoin name system. Actually, what you want to do is like just pay at Robin. Don't pay to an address. Don't explain. Like, my mom doesn't care about addresses. Like, she doesn't want to see that weird string because it makes her scared. We shouldn't show that to people. Another huge problem, of course, is key management is hard. I have no idea how to solve it, but I think we should try to solve it. Like, it should be clear that this is one of the big problems that we need to solve for global adoption. Password managers are one solution, maybe-ish, but it's basically giving custody to Google or to Apple. Not sure if that is super satisfying, but not quite sure. It's something we need to talk about, though, or we need to focus more on. And also, users should not be exposed to protocol details. Please don't explain to people that it's Lightning or it's on-chain or channel management. All that stuff is completely irrelevant. Just look at Apple Pay. Apple Pay doesn't tell you about like, oh yeah, there's SSL in the background and we are using this kind of server. It's not necessary. It's counterproductive. It's harming the protocol, or like it's harming the usage if we are trying to explain these things to users. I think we should not even try. We should try to hide it as much as possible. All of that complexity needs to be transparent. It's our job as engineers to make the user not having to care about these things. And another thing, we need simple units. Like, this is madness. Like, like 8 decimal points, 8 decimal numbers. It's extremely unintuitive, and it's cognitively expensive, and it creates this loss aversion. Like, this is scary. To normal people, this looks like, oh my God, I'm gonna do something wrong. I don't wanna deal with that. I better not touch Bitcoin because of this. And the Bitcoin brand is already strong. Like, we do have also that Bitcoin symbol, which makes a lot of sense. Yeah, this is even better than the dollar symbol. It's absolutely clear. It exists in Unicode, it's just great. And Satoshi even said, well, eventually just move the decimal point. We're doing it for now, but eventually just move the decimal point as Bitcoin becomes more valuable. And what are we doing? Well, we're trying to explain sats to 1 billion people. I think that's complete nonsense. Sats is like such a strange concept. Like, in the euro system, what are you using? Well, euros. In the dollar system, what are you using? Well, dollars. In the Bitcoin system, well, satoshis. That makes no sense, and it's like not the user's expectation. And I actually have friends who are trying to like explain Bitcoin to normies at Bitcoin meetups, and they're trying to explain that concept of satoshis to them, but they are just using bitcoins. It's the de facto standard for normal people. They are not saying, well, this is satoshi. They are saying, I bought some Bitcoin, and I mean, like, I bought $500 worth of Bitcoin. So I'm a big supporter of BIP 177, which just says, get rid of sats and rename sats to Bitcoins and make it simple. Make it just like how users are, make it match users' expectation. Yeah, this is simple and familiar. This is what people expect, and it helps them to actually, yeah, it fits their model of what they have. But then people are, oh no, the 21 million meme, you cannot get rid of it. I think that's just like, this is the worst argument actually, because if you think about it, the unit buys, if Coinbase would change from would change the name of sats to bitcoins, people would go crazy. I think we would have hyper-Bitcoinization by tomorrow if you could buy 1,000 Bitcoin for $1. People would throw money at it like as if there is no tomorrow. So if you care about the price, which is actually caring about the 21 million meme, you should definitely change it. And yeah, that would also lead to more decentralization because the unit bias keeps people from buying it. Like many people are just, it's stupid of course, but it's stupid of us that we are saying, oh, these people are too stupid to get that the unit bias doesn't mean anything. But it is there, and it is a huge factor, and we should design for users and not for us smart people. All right, the summary. I think people like Satoshi and Jack Dorsey, they are right. Store of value requires medium of exchange. Bitcoin will not be valuable in the long run if we don't manage to make it successful as a payment system. And what we need for payments is, on the one hand, scalability, on the other hand, privacy, and we need great usability, like Apple-level usability. And otherwise, if Bitcoin is not used, if it's not used, it won't be valued. Thanks. Not sure if I have time for questions, but I think it was quite clear now. Yes, please. Oh, that's a good point indeed, yeah. You can do like economic finalization, basically something like if you double spend something, then you get slashed. That is one option, of course. Before that was replaced by fee, people just accepted zero-conf transactions, and that also worked for lots of people. Of course, there's a risk of the transaction getting reversed. But if it's just 1% or less than 1%, then I guess you're fine. But yeah, it's a good point. Definitely, you need instant finality for payments. Oh yeah. I actually think it would be better to decrease the block time than to increase the block size. Any more questions? Yes? Ha! Not enough, no. Is it highly valued? I don't know. Why is it not at $1 million? Why isn't it like the #1 payment system in the world? Isn't it like undervalued by a factor of, I don't know, 1,000? To what it should be. What it's supposed to be. If it would be the #1 payment system in the world, what would be the price of one Bitcoin? I think it's highly undervalued, actually. By orders of magnitude, yeah. Yes, please.
You were saying we needed to be a medium of exchange for payments. Are you thinking mostly for physical goods, or what about like maybe other, I don't know, digital tokens? Shouldn't speak about it.
You mean like stablecoins or? Sure. Stablecoins have a huge advantage, of course, right? There is just a cost to using Bitcoin because it's volatile. And as long as that volatility is relevant, you have to price it into your goods. And that's a disincentive to use Bitcoin in the first place, which of course sucks. But on the other hand, stablecoins have that obvious problem that they need a centralized party. And we don't know any way to build algorithmic stablecoins without any centralized party. So I think it's decentish intermediate solution, but I would like that Bitcoin just gets established, or that we manage to establish Bitcoin as like the leading payment system in the world, and then people price things in Bitcoin, and then you get rid of that issue. It's a big dream, and I don't know, like I know it's unlikely, but I think it's worth dreaming. Yes, please. Mm-hmm. Uh, Yeah, this is another level of complexity that creates loss aversion. I think as developers, it's our job to like keep that from users. We should just update in the background and not make them too worried about whatever signature scheme they're using. Actually, they should not see the signature scheme at all. It should not be their business. You cannot have perfect decentralization, I think. And I think the more it scales or the more it gets adopted, the more the average person will just have to trust a lot of people down the line. But I think that's unavoidable. I think you cannot, it would be ideal if everyone would just read every BIP and so on, but this is just not going to happen. I think it's just unrealistic to assume that, so we should not try that. Yes, please.
Value of Bitcoin, whether it's where it's valued now, where it should be valued, and you said several orders of magnitude, wouldn't the value be what's the cost to maintain the integrity of the blockchain rather than the store value? So it becomes how much do miners get paid in order to not compromise on security, in order to have a frictionless system, in order to have the system there and it's secure and always omnipresent, decentralized, and available. So if you took out the store of value argument, which Satoshi said, and it sounds like you're agreeing with, then what is the value of Bitcoin?
Well, the value of Bitcoin, or the original vision of Bitcoin, was a peer-to-peer electronic cash system. A cash system that anyone can use and you cannot exclude anyone from it. Like, it's a human right basically to use it that is just granted by cryptography instead of people. And I think that's a fundamental value that we as a species should thrive for. And that is, I think, good for society in general. And that's the key value of it.
But is Bitcoin at 100,000, let's say, versus at 1 million or 100 million, to take an extreme example, like an edge case, wouldn't the chain still exist and function without being at those levels of valuation? Like Bitcoin could have value without it necessarily being priced at a higher value.
I'm sorry, I don't get the question.
I guess the question is more in response, like, how do you measure what's the value of Bitcoin, the monetary value?
The market measures it, no. The market measures it, like I don't measure it.
Let's say the market's not correct right now, that it's not undervalued, that it is, maybe it's overvalued.
Oh, I think Bitcoin as it is correctly valued by the market. I think Bitcoin, I think because of the block size war, we actually made a lot of technical mistakes that led to problems in adoption. And I think if it would have adopted as well as it could have adopted ideally, then it would be well valued orders of magnitude higher. Currently, I think the valuation is justified. I don't think, I think it's a technical problem. I think we haven't solved the technical things that we could solve, that are like hard to solve, but they are probably solvable. And if they would be solved, then Bitcoin would be worth values of orders of magnitude more.
I'm just posing the question that thought that almost be careful what you ask for Satoshi, that if it's not a store of value and that the real value of Bitcoin is as a transaction mechanism, the blockchain itself without the store of value may not be as highly valued as with the store of value argument.
I'm not saying not a store of value. I'm saying the store of value will not survive without payments. That is the hypothesis. Or like that's the argument I tried to steelman here. Yeah. Okay, cool. Thank you. All right.
Alrighty, all glad there was some spirited questions there towards the end. We're going to go on a 15-minute break before we have our last two talks of the day. So be sure to be back in here by about 2:45. That's when we'll be starting our next panel. Thanks. Alrighty, y'all, welcome back. And now for our final panel of the day, we have Alex Lee moderating from HRF, Elizabeth Stark from Lightning Labs, and Neha Narula from MIT to talk about Bitcoin's future in the era of quantum computing and AI.
Hi, everyone. My name is Alex Lee. Thank you for coming here. So the title of this talk is The Forest in the Trees, Bitcoin's Path Forward in the Era of Quantum and AI. I remember last year at last year's OPNEXT, everyone wanted to talk about JPEGs, right? Spam, JPEGs. Should people be allowed to put JPEGs on Bitcoin, blah, 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 blah. And a lot of people are looking at the trees, others at the forest. But right now, what are we missing in Bitcoin? For example, is quantum something that we should be worrying about? And I wanted to get started with you, Neha.
Okay, so first of all, thanks to Blockspace Media and everyone for having me here. Really happy to be here. It's been a great conference. So look, there have already been, I think, at least 4 talks about quantum at this conference already. So, clearly it is something that we're very worried about, something that we're working on. And I think that's the right move. But I think it's really interesting to ask, what is it that we need to do? What is not necessarily being done? There is a lot being done, which is great. But what needs to be done to actually move us forward to solve the problem? So if we work backwards from in 3 years, and 4 years, and 2.5 years, however long it takes, we have a version of Bitcoin that is secure in the presence of a CRQC, a cryptographically relevant quantum computer. What is it that we've had to solve on the way to get there? And I think maybe a little bit of what we're missing is the holistic view of the trade-offs and the hard decisions that we're going to have to make. This is something a bit unlike anything we've ever seen before, I think, in the sense that there's no easy answer. There's no clear way to move forward that is great in every dimension. We're going to have to make some trade-offs. We're going to have to either make signatures larger or slower or both, or we're going to have to give up on some functionality. We're going to have to coordinate a lot of complicated changes. And the question is, how do we all come together and decide how to make these trade-offs and articulate the trade-offs, not say things like, hey, everything's going to be great. We all got it. It's done. It's going to be solved. It's awesome. I mean, maybe there's a role for that. There are some people who are optimists, and that's wonderful. I'm the type of person who's a realist and likes to look at what actually needs to be done. And I think we have to have those hard conversations to move forward.
By the way, I'm both an optimist and a realist. You kind of, if you're building, you need to have the optimism, right? But from my standpoint, first of all, I am certainly not a quantum cryptographer or an expert in this field. But I've been talking to the community and catching up on a lot of what's been going on lately. And something is pretty interesting. As of maybe a month ago, I felt like I was living in 2 alternate universes. One where the developers were on delving Bitcoin and on the Bitcoin dev mailing list and going to developer conferences and talking about this and working on it somewhat quietly, and one where people were screaming about no one doing anything about quantum. In the last week, it feels like something has changed. How many people here are on the Bitcoin dev mailing list? So I've just been catching up this past week, reading everything the devs have posted. Presidio Bitcoin on Tuesday published a Bitcoin quantum paper, highly recommended for folks that maybe aren't as in the weeds on this, the trees. And they said that as of 2024, 5% of messages were related to quantum in some form, 20%. We're now over 50% through March, and I bet April's like even higher, just from my anecdotal perspective. So this is absolutely something the developer community is working on. Now, what Neha mentioned in terms of what's missing, there is a degree of translation. So something I do a lot as CEO of Lightning Labs is I take what our team does and our great CTO, who by the way is the fastest talker in Bitcoin, deep in the protocol level and translate it to the broader audience. And I do see that there is a role here, and we have papers coming out. We have the developers writing more broadly about this into what the implications are, again, the trade-offs as well. But the idea that no one is doing anything is now easily refuted because they clearly are working on it. And by the way, I will say, if somebody is looking for a plan from a centralized committee with a timeline now, especially, that's not how Bitcoin works, right? Our decentralization, our built-in freedom are critical to the way this community develops. We have this group of developers in the broader community and technical community all working on this, but we are not a centralized planning community, and that's part of what makes Bitcoin so great and so valuable. So the devs are deving. There's a lot out there that people are working on, and now they will continue to do so. By the way, the Shrimps paper just came out in late March, I saw, so there's so much progress. Great talk from Jonas just now, and we're going to keep working on this, and I believe we will come up with the technical solution, and of course the social side, which is a bit more complex, and I'm sure we'll be talking about what to do there.
Yeah, every day there seems to be a new signature scheme or an updated signature scheme that's way more efficient. There's new quantum research being done every day, and developer activity is skyrocketing. But the hard part of upgrading quantum may not be the technical side. It may be the fact that we are a decentralized committee that does not have a centralized leader or a board of directors or like 1 to 5 people that can just order people to do things and push things down everybody else's throat. So do you think that the political difficulty of getting consensus, agreeing on a signature scheme, yada, yada, is more difficult than the actual technical challenge of finding a good signature scheme and getting that upgraded in a soft fork or hard fork?
I think that's a great way to put it, which is, why, like the entire internet has to handle this problem, right? They have to upgrade to post-quantum cryptography, but we don't spend hours and hours and days talking about, oh no, it's going to be so challenging for Google to do this or Cloudflare to do this. No, because they're run in a completely different way. And like I said, if it were the case that from a technical point of view, there was a clear winner, there was a clear way to move forward that, on all dimensions was superior, security, throughput, latency, cost, all of it, then I think it would be a lot easier. But it's because we're going to have to pick a point in the trade-off space that this becomes a lot more challenging. I think we can do it. And it's, I don't want to just call that a social problem, though, because it's not just a social problem. It still is a technical problem. It's a technical problem. It's a communication issue where we have to articulate these things and we have to make the trade-offs, the technical trade-offs, really clear to everyone so that they can understand them and that they can weigh in and that they can form an opinion. So there is that element of translation. There is that technical work of creating that clarity and understanding. But it is what makes it more challenging in our world.
Yeah, and one thing I think it's important not to lose sight of is, we're all here in New York City, my hometown, but obviously Bitcoin developers are all around the world and the communities all around the world. And we have so many people in authoritarian regimes, over 70% of the world, we heard from Anna earlier, and emerging markets. So taking those user stories and perspectives into account with these plans is also going to be critical, and reaching out to those folks. And I know that's something that HRF is working on quite a bit as well, and something we in the Lightning community are passionate about. But at the end of the day, Bitcoin's leaderlessness is both a blessing and a curse. I believe it's ultimately a big blessing. And the way that I like to think about control of Bitcoin is, well, who controls Bitcoin? No one and everyone, right? And we as a community are putting together proposals. We're going to argue about a variety of things, including coins that will not be upgraded or coins that are lost. And I do believe we're going to come up with a solution, and I do believe we're going to move forward. And the way this community works, by the way, is, okay, if you don't like something that's going on, guess what? You have agency. You can do some research if you're capable. You can write some posts around it. You can donate to people doing so. You can talk to other people in the community. You can organize events. This is how Bitcoin works, so I welcome everyone. Thank you for being here at this event to contribute and get involved if this is something you care about.
Moving on to the next topic, one of the few things that gets more mindshare than quantum in the crypto and Bitcoin space right now is definitely AI. No matter where you go, whether it's San Francisco or middle of nowhere, anywhere in America, you'll be hearing about AI, how people are using AI. So in the future, do you think that Bitcoin will be the predominant money of AI agents? Will most of us be using AI agents that have a Lightning wallet or Bitcoin wallet, or do you think most transactions will still be conducted using fiat?
Well, I'm biased. Because I do love Bitcoin. But at Lightning Labs, this is something that we have been working incredibly hard on. And the way that we think about it is, okay, well, if an agent wants a bank account, well, they're not a human. They can't KYC. They don't have identities. And so Bitcoin is this neutral, global, decentralized protocol that they can adopt. So we've been building a whole suite of tools. In fact, we created something called the L402 protocol, which has been in production with quite a few of our products for years now, back in 2020. before agents were cool, before they really existed in this form today. And so we were able to then effectively slot that protocol in. And what it does is it enables authentication with something called macaroons, a bearer credential, if you will, on the basis of the payment. So you don't need logins, you don't need passwords. It's great for privacy, and it's great for paper API call and digital goods and a variety of means of transacting for agents. Early in the world of Lightning, we used to talk about it's upward bound, which we don't have an exact number, but it can do many, many, many transactions per second, more than Visa. Of course, this depends on liquidity in the network and so on. And people would say, well, why do you need that, right? And no one really asks that anymore because it's obvious, at least to those of us deeper in the AI world, that agents and machines want to transact at a high volume with very low fees, often in very small amounts, all of these things that Lightning can do. So we at Lightning Labs have been building a number of tools. There's something on the sell side called Aperture, which enables developers to easily hook up, say, an API to an endpoint and accept Lightning payments. And then on the buy side, we have something called LNGet, kind of like wget if folks are familiar with that. And then one of our devs actually just built something called L402 SDK. So if we can pull up this quick demo around buying things with the L402 protocol on Lightning that was just created last night.
Hello, I'm Dario, protocol engineer at Lightning Labs, and today I'm introducing the L402 SDK, an SDK that gives AI agents the ability to autonomously pay for L402 gated APIs. We have different variants of this SDK in many different languages, in Rust, TypeScript, Python, or Go, and they are all available on NPM or in Pipey. To showcase this, we have built a little demo that is an L402 explorer that retrieves the data from the 402index.io and allows you to, by communicating with an LLM through a chatbot, gives you the ability to retrieve data and display it in an intelligent way on the front end. So let's see, for example, I ask my AI to read me a Fortune cookie. The LLM will be able to autonomously retrieve the correct endpoint from the L402 index using the L402 SDK and give back a Fortune cookie after having read it and paid 1 sat for it. So extremely cheap. As you can see, this is what you can build using the L402 SDK, and it's pretty awesome.
1 sat. Pretty cool, right?
Moving on to the protocol part of Bitcoin, it seems like 5 years ago, everyone's go-to is Bitcoin Core. And if you were here last year at OPNEXT or you pay any attention online, there's been a lot of heated debate over alternative protocols, forks, BIPs. So I wanted to ask you, Neha, how do you think the Bitcoin protocol will evolve in the future? Will we all be using Bitcoin Core, or will there be many diverse and widely used implementations?
Yeah, so Bitcoin Core has not existed as a phrase the entire time that Bitcoin has existed. It didn't come around until there was kind of a bit of a divide within the Bitcoin community about, I think it was around the time of the block size wars. And so, this notion of like this group, this very specific group that is behind a client implementation was something that kind of developed a bit later. And so I want to point that out because people might not know the history. And, it is currently the predominant implementation on the Bitcoin network. And it's really funny because in most of security and in most of software development, it's not a good idea to just have one implementation. You actually want to have diversity. You want to have redundancy. You want to have multiple implementations of something. But that's not exactly true in Bitcoin because of how important it is for the network to remain in consensus. It is absolutely critical that the network as a whole agrees on what the canonical blockchain is. And if we had multiple implementations, there's a chance that they could diverge, that we could have bugs, that we could have what we call a split brain. People might disagree. It could cause chaos. There's a project happening right now in Bitcoin that I'm very excited about called the Bitcoin Kernel Project. This is something that's been attempted for years, many, many years. And it's an effort to try to really encapsulate and modularize consensus inside of Bitcoin. So what you might not realize is when you run a Bitcoin node, you are running so many different things. You're running a wallet, you are running a GUI, you are running the consensus layer, which validates blocks, but you're also running a peer-to-peer network that moves blocks around on the network. You're running like an address manager. You're running all these different things. And the Bitcoin kernel project is an attempt to really take that consensus part, encapsulate it, make it modular, and then break it out. And so what that might actually enable, which I think is incredibly exciting and incredibly healthy for Bitcoin, is the ability for us to build other implementations. Now, this isn't totally a solution. It's not like this is going to solve everything between the NOTS folks and whatnot, okay, and the filter people and everything. There are some disagreements that actually live inside consensus, and that's not going to settle these arguments, But at least for people who want to build a different type of wallet, build a different type of indexer, build a different kind of peer-to-peer network, do things in a completely different way, you can do that safely once we have the Bitcoin kernel. It reached a milestone recently that is pretty exciting, and it's working to get even further out. It's a project I don't think a lot of people know about necessarily. Sebastian Kung's leading it. And I just think it's so important. And it's a sign, I think it would be a real sign of maturity for our industry if we could get to the point where we can have multiple implementations. We can have people who want to write in Rust. We can have people who want to do an implementation in Go. Not that there isn't an implementation in Go. Lightning depends on it. But right now, there is a risk. There's a consensus risk with that. And so to be able to do this safely, I think would be really exciting. And maybe might even lead down the road to being able to safely have disagreements about consensus in the future and somehow have a way to resolve that. So that's a direction that I'm really excited about. I do think eventually we will have more clients than we have today, and that would be very healthy.
Any thoughts on that, Elizabeth?
I would say from a high level, on the Lightning side, we don't have the consensus element, right? So we do have the bulk spec. We actually have a meeting of spec developers coming up where they're all meeting up IRL in person. And the community collaborates on it. Lightning is its open standard, but we don't have the consensus part that the base layer does. So it's interesting because in some ways you get the base layer to go more in the direction of having multiple implementations that are widely used. So interesting project, excited to hear more about it.
So I wanted to add on a freedom tech angle. I work at the Human Rights Foundation. We're a nonprofit that promotes human rights within authoritarian countries. And a lot of people used to ask me, why would a human rights organization support Bitcoin, right? What does Bitcoin have to do with freedom? And at the end of the day, Bitcoin matters because Bitcoin is an essential human rights tool for countless human rights activists and dissidents around the world who rely upon it for fundraising, for day-to-day living, just to survive when governments and authoritarians around the world shut down their bank accounts. So I wanted to ask you this, Elizabeth, right? Why does Bitcoin matter to you and your work at Lightning Labs? Is Bitcoin just a number go up technology? Is it just something where you look at you open Robinhood or you open Kraken or Coinbase, or maybe you're on your self-custodial wallet and you look at the fiat value every day and number go up is good? Or is for Bitcoin to survive, for Bitcoin to be what you want it to be, it has to be digital cash that people can rely on and spend?
Well, thank you for that softball question. So human rights has been something that I've been passionate about for a long time. And even when I was studying it in university, I was very into the internet and technology, and human rights was another area that I really cared about. And the centralized theme that bringing it all together is one of freedom, right? And to me, without decentralization and freedom, Bitcoin is not Bitcoin, right? And we hear about maybe larger financial institutions getting involved, and at the end of the day, they have to accept that this is the nature of Bitcoin, and if they want something that is far more centralized, we are not the community for that. They're welcome to use it. The nature of Bitcoin is it is neutral, and enemies can use it, right? And so from my perspective, the work that HRF has been doing, and I've had the opportunity to meet so many of these activists and human rights defenders that rely on Bitcoin. And those stories are critically important because at the end of the day, in a community like this and the folks that we have here today, we have to ask ourselves, why are we here? This is the forest part, right? And I believe it is to defend those values of decentralization and freedom and to empower people around the world. And yes, we could have a more optimized centralized chain, but that would not be Bitcoin. So from my perspective, this is the kind of thing that actually like gets me up in the morning and gets me super excited. I really believe in building a values-driven company and being part of this community. The way that I think about it, Bitcoin itself is a movement, and the human rights part of it is inextricably intertwined with what we are building in this community. And one very cool thing, and I invite you all to go to the Oslo Freedom Forum, that I'll be speaking there as well around Bitcoin and AI. And by the way, a lot of activists are now using AI tools, but of course you have this scenario where you have so much centralized tech with AI, and so much of it is proprietary, and then Bitcoin is open source and decentralized. So I'm very excited at the idea of bringing more of the decentralization and the open source nature to the AI part as well, and bringing the community along with it. So right now, it also feels like, by the way, in the past 6 months, there's been such a massive acceleration, like, in terms of vibe coding, in terms of AI-assisted coding. My co-founder, fastest talker in Bitcoin roast beef, is now 99% agentic coding. We have devs that are 100%. Yes, they're still giving instructions around architecture, but we've seen this massive acceleration, and we need to be using this for good, for freedom, for defending human rights and democracy globally.
Yeah, just to build on something that you said earlier, I think oftentimes people have this misconception that the idea of, there's folks who are really excited about using Bitcoin. Bitcoin is money, Bitcoin is for freedom, getting more people onboarded into it, like actually using it as a monetary tool. And then there's people who are very interested in it from an investment perspective, right? Digital gold, number go up, et cetera. And I think what people might not appreciate is that these things, like, you cannot have the latter without the former. You cannot be digital gold. Bitcoin is not valuable in that way unless it is decentralized, unless it is freedom technology that people can use. Otherwise, if it's just something that a lot of large financial institutions are holding, and people mostly access it through custodians or through ETFs, like go join the Canton network or something, right? Like what are we even doing here? Why is that interesting? It will lose the plot. It will no longer have that narrative, and it will no longer have monetary value. And so you need to be bought in to the freedom tech, the global, this is something for the people, I think, narrative, in order for the digital gold narrative to even make any sense. And I think sometimes people don't put those two things together. We should all be on the same page.
Good luck on Bitcoin, though. I like to say, like, welcome to Bitcoin. You can't tell anyone what to do. So we'll have differing opinions. But Neha, I was reflecting on how we did a talk together ages ago during the pandemic, where you made a comment about, like, we are not here for Goldman Sachs. We're not building Bitcoin for Goldman Sachs, and that got a lot of uptake. Now, look, Goldman Sachs is welcome to use Bitcoin. Anybody can use it. But at the end of the day, this is a much broader movement with a much bigger mandate and set of values.
So we have a couple minutes left. I just wanted to give both of you a chance to comment on anything that we might have missed, whether that's related to quantum, whether it's related to AI agents, payments, or Bitcoin as a tool for freedom technology.
Quick point on quantum. So in the past week, things, again, have really accelerated. But my co-founder and our CTO at Lightning Labs put together a cool proof of concept, something that had been discussed within the community for a while. There are quite a few posts on it. And he just went and coded it. And again, his army of agents helped him out with this. So check it out. And what it does is it uses a ZK Stark, no relation, to prove that somebody is the rightful owner of a BIP32 seed, because those are actually quantum resistant. So in the event of, say, an emergency hard fork, anybody that's using a wallet with a BIP32 seed could actually prove ownership in a quantum secure way, assuming certain things were disabled and there was a soft fork and whatnot. And it took, in his initial experiment, less than a minute to prove in 1.7 megabytes, which is very large. But then somebody optimized it for like 222 kilobytes, but then it took 3 minutes. But anyway, the community is working on these things, and it's exciting to see the progress. And he's also maintaining a repo of technical projects on the quantum front.
Yeah, I guess I would just urge people not to get distracted by the latest and greatest battle on X or Twitter or whatever. Today it's BIP 361. Should we freeze? Should we do this? Take a step back. In order to make progress on these questions, It's going to take a lot more than proofs of concept. It's going to take a lot more than Twitter flame wars. And quite honestly, it's going to take a lot more than individuals inventing cool ideas and putting them out there. We're going to have to systematically put all of this together. We're going to have to evaluate a lot of different options. We're going to have to get on the same page, and we're going to have to figure out all the corner cases and move this forward. So that work is hard. That work is oftentimes not, the glorious invention on the mailing list or whatever, but that's the stuff that actually makes progress. And that's the work that I'm excited to do, and I know a lot of other people are excited to do too.
And in an era of increasing centralization and proprietary nature from the AI front, to me, Bitcoin is this pinnacle of decentralization and freedom. And I believe that there'll be more and more centralization, and we as a community will be fighting back against this and producing solutions, sometimes in a messy way. But that's how Bitcoin works, and that's why we're all here for it.
Yeah, and if you're a free and open source developer working on Bitcoin, Nostr, AI, eCash, for related freedom technologies, definitely check out the Human Rights Foundation. We give grants to support free and open source software development. We're out of time. Thank you so much, Neha. Thank you so much, Elizabeth. See you around.
Thanks, Alex.
Who in the world is mining Bitcoin in Australia right now? I mean,
I don't like a company going bankrupt, but whenever something like this happens, you can go into Pacer, find the court filings, and then you have all of this juicy open source information about who is involved in these things. Some of the names that have surfaced from this, there's some really weird stuff in here. Like, for instance, is the Chicago Blackhawks hockey team? This is real for $1.26 million.
At first blush, you might be like, well, yeah, of course, just, check the boxes, dude. But if
Just
you
log
are,
the trade, bro.
Yeah, just log the trade. That's not how it works.
Now, this is very much a he said, she said story.
Riddled with drama.
Anchorage Digital is a platform for everything that an institution could need in order to interact in the digital asset ecosystem. If you are someone looking to buy assets, looking to hold assets, looking to stake, collateralize, trade derivatives, we provide the entire full suite, one-stop shop that any institutional investor might need in order to utilize digital assets. We have 1,000 clients on the platform and growing more every single day. And we are increasingly expanding the offering to support institutions looking to build businesses in the digital asset ecosystem. Folks that are looking to utilize the platform in order to integrate it into their bank, into their fintech, into their offering. That part of our platform is growing really nicely. And then additionally, we are getting big into the stablecoin business, looking at how to allow people to issue stablecoins, how to settle stablecoins, how to move stablecoins in the ecosystem.
All right, good. I've got an announcement. Alrighty, y'all, it's almost time for our final talk of the day, but a quick housekeeping thing. We have found a passport for one Daniel Howard, and it is at the ticketing booth by the entrance. So if you know Daniel or you are Daniel, we have your passport. Make sure to pick that up before you head out today. All right, and with that, For our final talk today, we have a fireside chat with Jeff Park and Mark Hochstein of Galaxy to talk about the current investor climate, how investors are feeling about Bitcoin, especially with quantum computing risk looming in the background. So without further ado, please welcome our next two presenters to the stage.
Thank you, Colin. Good afternoon. How's everyone doing out there?
By the way, this is my favorite slot where we get to be the blockade between fun people wanting to access the open bar. So
yeah, I mean, we're all that stands between you and PubKey. You know, it's so we've got quite a job here. My name is Mark. I work at Galaxy on the research team. I'm going to interview Jeff. Jeff, just give everyone a very brief introduction.
Absolutely. Hi, everybody. I'm Jeff Park. Until very recently, I was the CIO of ProCap Financial, which is one of the Bitcoin treasury companies that went online last year. Before that, I was the head of alpha strategies at Bitwise Asset Management, mostly famous for having launched the Bitcoin ETFs, amongst other products, where I continue to have the privilege of being an advisor. Thanks for having us here.
Yeah, so, and apologies, we're going to do a little bit more quantum dooming before we get to drink. But one thing that I wanted to pick up on from one of the earlier sessions today, when we had some other investors out here, they were talking about how they're looking at quantum risk. One line that really stuck with me was when Robbie from BlackRock said, let's stop talking about timelines. That doesn't help. Tell me what your thoughts are on that, and do you agree, and if so, why? Why is talking about timelines for quantum a problem?
Yes, I'm glad you're asking this, because that line also stuck with me very deeply, and I agree with Robbie. And really, it's because when we talk about timeline, there's an anticipation of it being almost like a binary digital event. And the reality is, the way that quantum is approaching us is more likely to be a probabilistic distribution of accumulation of data points we will discover along the way. Meaning, it's not like Y2K, where we know there's a finite point in which a switch turns on. This is a developing
and exactly
situation.
when we knew exactly
right.
We knew it was going to happen, and we knew down to the second, right?
Yeah. So when people talk about the timing of quantum's arrival around 2029 to 2032, usually what they're saying is that they think there's a certain probability of that event, and that probability is about 50%. But the problem with that approach is if you say something's going to happen in 50% likelihood 7-8 years from now, well, what does that mean for the next 2 years, or next 3 years, or next 4 years? And so that exercise, I think, does become immensely useful when we're talking about things that are within underwritable duration, like, say, 1 or 2 years. But anything beyond that, it is hard to kind of grasp at the importance of that timing. If you think about credit default swaps, for example, credit default swaps trade 1 year to 5 year, and the spread, of course, gets wider as you go out, because the assumption is the company is more likely to default every year that goes by, but not likely to default next year. So the idea here is, well, what is the 1-year swap rate for quantum's arrival? What's the 2-year swap? And without knowing that spread, it's really hard to know that digital jump from 0 to 50 7 years from now. And I do think, as Robbie was also articulating, the danger of having a finite expiry like that is that institutional investors will look at that as a way to imagine a fatter left tail, as he described it. Even the narrative building in which enlarges the probability of extreme severity and loss events to the downside is more than enough to obfuscate the path dependency for the next 7 to 8 years as to what the actual kind of progress of that arrival could look like.
So, in your view, as an institutional investor, as someone who works with institutions, do you think the community, the devs, are moving fast enough?
I think there's definitely an acknowledgement now than there was a year ago that this is something that they will continue to be proactive about. And I think there's also this element of what we need to be precise about defining this time to break, because really, there's 2 ways people are imagining for the arrival of quantum in the timeline. One is kind of the discussion around the actual point in which cryptography can break. But then the other component is how long will the actual kind of duration of that like attack itself last? You know, are we talking about a slow-moving kind of moment or like a faster clock? So the duration of the attack being possible within 10 minutes is actually a critical window because it changes the fundamental discussion around the attack surface for the Bitcoin network. So I think institutional investors are becoming more aware of the nuanced dialogues to be had underneath there. And they're being more thoughtful about it. But here's the really interesting thing. I always imagined, before the Bitcoin ETFs launched in 2022, 2024, that one of the really most interesting case studies we will be having is how these technical effects will change the financial wrapper and therefore the financial outcome based on who the actual issuers and sponsors of these ETFs might be.
How do you mean?
So what I mean by this is, just a fun little side story here. At Bitwise, we used to manage the NFT index fund, which you may know. NFTs were a theme back in the prior cycle, for which we had a top 10 market cap weighted NFT index fund. Bored Apes Club was a big component of it. And by having those NFTs, there were airdrops, right? And so
So you would get ApeCoin if you already held
That's right.
one of the non-fungible Bored Apes.
Yeah, this is one example of the many idiosyncratic things that happen in crypto land that ETF issuers have not necessarily thought through every ramifications of what that looks like in a 40 Act fund or even a private placement fund. And so you have these dividends, if you will, of airdrops, and now the issuer has to decide, well, what do I do with these coins, and how do I monetize it? What's the duration and how I monetize it? And you just realize, actually, this is no longer a passive index strategy. There's an active overlay, right? Someone is making some decisions about certain events that can be known and unknown or unknown and unknown.
Mm-hmm.
And so what I'm alluding to here is, if there's a moment for Bitcoin to achieve a hard fork, which of course has happened in the past, but not in the wrapper of having the ETF be a dominant source of market flows, there's going to be a really interesting question as to how do each issuer deal with the ramifications of these events. And I think that's why so many people are interested in understanding how they're streamlined versus the custodians, right? There's a reason why Coinbase has emerged as kind of the common choice amongst issuers so that they can minimize the surface area for divergence. But we all know VanEck has an ETF that custodies with Gemini. So, you know, I'm having been in this space long enough, I am old enough to remember that depending on where you held your coins on which exchanges, sometimes you got the hard forked assets and sometimes you didn't.
Right.
And that means some people got like a dividend and some people didn't get a dividend, and that total return just looks different. So I think this is the evolution of the conversation that we are probably going to see in the asset management industry. Right now, we're dealing with a lot of theory, right? We're talking about technical theories, about error correction and logical kind of elongation for duration. And then there's also this like social component as to like the moral question of what to do with the lost coins. But then the really interesting stuff is like, what are the practical implications that will arise out of like some of the actual solutions that are likely to be implemented, which I think is actually quite fascinating.
How much do either the contracts, the B2B contracts between the ETF issuers and the custodians, or the public offering memoranda for the ETFs, how much do they go into, you know, if there's a hard fork on this asset we're holding, who gets the rights and what happens? Do they contemplate this at all?
So this is a perfect case for probably Claude to actually go through all the filings and see if there's divergent languages. But I guarantee you, if I had to guess, that they allow for broad disclaimer of languages in delineating all the ways that you can get screwed. It's a risk disclosure mechanism in the 40 Act, 33 Act fund space. And so you're probably not going to find any, you know, kind of prescriptive planning for things that will ultimately have to be decided later based on some of the developments we'll see. But what I will say is, and this is why I've always kind of been a big fan of Bitwise, and I'm of course a little biased because I used to work there and it's an advisor, but I've always told people when the ETFs arrived in 2024, I know sometimes fees become the most kind of obvious thing to choosing which ETF you buy, and you know whether it's 15 bips or 20 bips or 17 bips, and of course fees matter. But you know I've always advised people, you know, try to work with the issuers who are most able to understand the critical issues at heart in crypto, and be a steward of your interests, your ethos, your recommendations, and actually drive capital towards achieving those outcomes. And I do think this kind of soft fork, hard fork event type of stuff will actually allow some of the ETFs to start maybe differentiating a little bit from a social capital away from also just being, you know, a liquidity layer for the Bitcoin spot market.
Well, that's kind of where I was going. Like, is there an opportunity for certain ETF issuers to amend their offering documents to say, hey, if there's a hard fork, we will do X to benefit you, the shareholder, something like that?
Yeah, so this is the interesting thing. You know, on the technical things, as challenging as like the timing is to be prescriptive about it, the reason why everyone cares so much, because they know intuitively the timing of the technical unlock is going to inform the timing of the social unlock. And the beautiful thing about most things that are technical, especially if you believe that, you know, as prior speakers were describing, you know, most of physics are going to show some exponential possibilities once error corrections can be reduced to a level, and it's predictable. The social consensus layer building is not, right? That actually takes a lot of time, and it actually has a lot of dynamism in the system where results can be a little bit unpredictable and chaotic. So I think the sooner people can have that conversation, I think the hope is that we can kind of parallel track solving that problem, which I actually think we all probably agree in this room is the larger component to the general community social mission of the Bitcoin ideology. And the thing that I have been using to describe to folks who may not be as familiar with quantum and kind of the questions of the lost Satoshi tokens that can range to up to, I think, close to 6 to 7 million coins, which would be a huge chunk of the existing supply. The way I've reduced this to an abstract level that like my son could understand about what this like almost ethical moral dilemma could be is that it really reminds me a lot of when like self-driving cars first came online by Tesla, and everyone loved to ask this question about the ethics of self-driving cars when, let's say you're in the car, you're the driver, and you're going full fast, and then you see like a family of like 4 kids or whatever, and you can either hit the family and save yourself, or you swerve and you hit a concrete wall and you die, but the family gets saved. Like, what is the right decision?
Right, for the machine to make.
Yeah, like what should the machine do? And what that question's always implying is a little bit of this like moral construct of like the interest of self-determination versus the greater goods for the community. And at this level, I think you can almost abstract away some of these conversations about how people are talking about what should we do with the coin? Should we freeze it? Should we not freeze it? Does it go to an estate? All of these conversations cater to some kind of abstraction to this. And you know, what I've generally thought through is most Bitcoiners, I think, are high agency people that are first and foremost self-determined and self-interested, if you will. And so in that sense, it feels like there will be more narrative building towards that preservation of like the monetary mission. And if you believe the monetary mission dictates some of these things for it to survive as the way it must survive, then I think you can almost backward solve where the community is going to ultimately find its conclusion.
I mean, when we talk about the greater good, something that's been in the back of my mind all day when we've talked about these scenarios in which, you know, the Satoshi coins get, you know, through some fork possibly get confiscated or burned. There seems to be this underlying assumption that if, and again, let's say that we can all migrate our own coins, right, to quantum safe addresses. But if Satoshi gets hacked by a quantum computer and the attackers dump the coins on the market, or they start selling the coins on the market, yes, it's 10% of the supply, but there seems to be this assumption that we can't tolerate this, that this is something intolerable, we have to prevent that. Even in that scenario, like Bitcoin doesn't go to zero anymore, does it?
That's right. So I think there's 2 risks and events here too that sometimes gets conflated.
Yeah.
One is actually even the movement of those Satoshi wallet coins themselves, I think, is a negative effect.
Oh yeah, that's a wick down right away, right?
Right. Even without entering the market as a sell pressure, if anyone saw those coins move, it would be automatically a negative event.
Right.
And this is actually kind of, I'll draw an analogy from like the oil world. When people go out on oil and exploration, there are these acronyms to describe the status of where the possibility of extraction that oil could be for monetization. And There's one where you say it's proven or unproven, or developed or undeveloped. And this kind of like dormant coin is what I would call like unproven, undeveloped, right? But the moment it moves, it becomes proven undeveloped. And then it goes proven developed if it gets sold. And so what I'm implying here is the big risk is actually that it's alive. And that alone introduces the possibility of supply, which is actually more material, in my opinion, than the actual decision node of whether they sell or not. Because it means that the denominator has effectively just changed overnight. So there's that. And then, of course, the bigger question being the selling pressure. And that then gets into a lot of weird things around geopolitics as to which supernation has to win the quantum race to then be a protectorate and where the interests lie. And then you can't help but see that the lanes of Bitcoin hyper-financialization is merging with some polarization through this conversation.
Right.
So it's actually almost impossible, in my opinion, to avoid introducing some geopolitics to Bitcoin, for better or for worse, in this particular conversation, the lens towards these.
So it's not just a matter of more supply coming on the market. It's that whoever it was who could hack Satoshi in this scenario, we're talking about nation states getting involved. Right.
Yeah. I think these are the things institutional investors are asking about. I think more than anything, their job, right, in this business of asset management is, of course, to make money for their clients. But the superseding job above that, if you would let me entertain the reality of it, is that they cannot lose the money. And they cannot lose it by having it go to zero.
Right.
Because it's one thing to make 12% a year and be well rewarded as an advisor. It's another to invest in something that goes to zero. And that is not about money anymore. That's about competence. And professional money managers have to weigh some risk to that optic and that fat skew, high severity event a lot more seriously than we might as principal investors for ourselves, because these are actual fiduciaries and agents of other people's capital. So their incentive alignment is actually quite different than yours and mine for our own investing.
So that's why the community is contemplating this blasphemous idea of burning these long dormant coins.
Yeah. Now, I think reality is, most likely there's probably going to be some kind of fork event, right? And it means that we are going to have one of those ex-dividend type post-block size war situation. And now what's going to look really different today versus the prior is, because the ETFs have become such a dominant source of the liquidity layer, it will have lots of wide-reaching ramifications that didn't exist prior. Meaning already, derivatives that sit on top of Bitcoin now are most often expressed through the ETFs, right? So the IBIT options market is actually quite large. At one point, it was almost half, maybe exactly half of the total open interest by the end of last year, taking share from Deribit. And how those things get resolved on Deribit options versus IBIT options could take divergent paths, and how the forward curve gets priced based on the timing of this actual ex-dividend effect is going to impact how risk takers come or come offline market. How you actually choose which counterparties you want to do these trades are going to look different. So for example, you might want to trade CME options because you know it has settlement clearing mechanisms where you're not taking counterparty risk. You may not want to trade these options with a crypto-native OTC prime broker because you think the event severity itself could maybe put them at liquidation and bankruptcy. So counterparty credit risk starts coming in. They're going to have different option price, even if the underlying economic risk is the same, because the counterparty risk. And so I think there's going to be really, really interesting things happening in the capital markets. Of course, this is not like the thing that we are here talking about wanting to promote the technological adoption of Bitcoin, but the reality is it's a financial asset. And there's going to be a lot of things around this where consensus building is going to have to arrive in a coordinated way, because it is ultimately a social experiment.
So getting back to geopolitics and getting away from quantum, so we had a report recently, and it's not entirely clear exactly what's going on, but it's been said that in the Strait of Hormuz, in this ongoing conflict in the Middle East, the Iranian officials are asking for Bitcoin from these ships that are seeking passage through the strait. There are other reports that say it's stable coins, others say it's yuan. Not entirely clear what's going on. But let's say, taking that at face value, So if that is in fact going on and Bitcoin is being used in this way, how does that sit with the institutions that you talk to? Does that mean, on the one hand, Bitcoin is working exactly like it's supposed to, or does it mean this thing has compliance risk, this thing has reputation risk? Like how do the Wall Street guys view this?
Yeah, so I kind of jokingly made a comment that Bitcoin is the Strait of Hormuz for freedom money in a way that we're going to find out just exactly what choke points look like for the financial system as it exists geographically in our maritime laws. And that's essentially what's happening, right? Because money that is good for American, that is also good for Iranian, is perfect money. And that should actually be lauded and celebrated, that we've actually found the medium that's solving people's...
Wait, are you saying that money is supposed to be fungible?
Well, look, I think we can talk about the actual mechanism of how that toll should be collected by Iran in an authentic way that would be beneficial to the Bitcoin network. Yeah. But what my point is more along the lines of if the case is that Bitcoin is used for this particular purpose, where they require censorship resistance and neutrality, it is almost like the most perfect case study of why we wanted to promote Bitcoin's adoption. And so if this happened maybe like 4 or 5 years ago, 6 years ago, with like the Gensler era, I think the crowd would have been a lot louder about illicit activities and Bitcoin is good for nothing. But I think enough kind of momentum and optimism has come into the crypto industry. I think also distrust generally in nation states have gone down, that most institutional investors, as I've spoken to at least, and it's a limited sample set, I think are more bullish about it. Actually, I think they'd be very excited by the idea that Bitcoin found its use case and that this may actually, in fact, be the sovereign fund adoption that we've all been waiting for. And when they say the sovereign funds are coming to buy Bitcoin, you know,
this is what they meant.
This is what they meant. They're not going out there and buying Bitcoin on Coinbase. All sovereigns acquire Bitcoin by seizure at some level or by having some national strategic stuff. That's what happened in America too, right? The US did not go out there and buy Bitcoin they seized it. Yeah. China did the same thing, they seized it. Iran is at this moment trying to now find a way, potentially, to weaponize their own construct to seize some Bitcoin. And I think that is actually what we're excited to see more nation states participating. And the point that I would make there on the settlement side, you know, Robin gave a great talk about how we must hope for Bitcoin to be used for payments in addition to a store of value to survive its original mission because of the security model will ultimately break otherwise. And we always assume that when electronic peer-to-peer cash system is discussed, that it's meant to be you and me buying coffee or beer at PubKey. But if you maybe just extrapolate one entity level above, you can almost squint your eyes to imagine what that could also be is exactly what's happening in Iran, which is Bitcoin's very useful for payments, but the payments have to be fairly substantial, where you really, really, really value neutral clearing, and you actually then can imagine driving value in a payment system of nations or corporates or institutions that can build some economic security.
Wholesale rather than retail payment.
That's right. That's right.
Yeah. So we're almost out of time, but one thing I really wanted to hit on to get particularly to get an institutional perspective. A couple of weeks ago, we had another Satoshi article. I don't want to get into debating the merits of that article, but I just think the meta question is interesting. Does Wall Street, do institutions care who Satoshi is at all? Does it matter to them in any way?
I think institutions and individuals are probably aligned here, which is that the more amorphous, the more decentralized, the more faceless that this whole ideology is as in its existence, that it has less attack vectors, less kind of points of failures. And as a result, I think they just see it as the same that we do, which is no one's that interested. It makes a good fodder. I think lots of reasonable people have arrived to similar conclusions, which is that it's unlikely, perhaps, to imagine even Satoshi might be one person. And those conversations, I think, are more likely a way to satiate some of the constant querying for trying to identify a singular person. You know, much like kind of we talk about Shakespeare was probably not one person, right? It's probably a factory of a bunch who came together under one pseudonym to be so prolific and abundant as they were. I think there's an interpretation amongst institutions, as I've spoken to, that maybe it actually isn't one person, but a collection of people. It could include people like Lance Essman, and some of those people may no longer be with us, and however they were able to shard the keys meant that none of them would ever have access to it. And that's enough, and that's okay. Like, we don't actually need to know the physicality of individuals to define the outcome, which is that these are probably not coins that will move.
So Wall Street does have to practice KYC, but they don't need to know your creator. I think that's and I think on that we have to end it. But thanks so much for listening. Thank you, Jeff. This is a great conversation.
Thank you. Thank you for having me.
Okay, and that's a wrap for us at OPNEXT 2026. Thank you so much for joining us here. Oh, I thought Colin was going to join me, but he'll be joining us later at PubKey. That's the next spot. We're done with the talks for the day. You get to enjoy some beer down at PubKey, America's Bitcoin bar. So we're going to take the train down there in a little bit. You have some time to go hit the hotel for a little bit or take a break somewhere else. We'll be opening the doors at PubKey at 6. If you want to get there early, you may, but the tab will get picked up starting at 6, going until 9 p.m. So we'll see you all down there. I believe the first hour, someone bought burgers and hot dogs for the crowd. So if you get there early, you might get a free one. Thanks so much again for joining us. If you're a speaker, a VIP, or a sponsor, there will be an email going out shortly about the location for this speaker dinner. And if you have any questions about that, feel free to come talk to me. Otherwise, feel free to mingle for a little bit. Doors will be closing at 4:30. We are going to start tearing down. So don't mind us as we do that. We have a lot to get done before we can get out of the venue. You guys have about 45 minutes to mingle if you want to, or hit the hotel before PubKey. Thank you again.
Who in the world is mining Bitcoin in Australia right now? I mean,
I don't like a company going bankrupt, but whenever something like this happens, you can go into Pacer, find the court filings, and then you have all this juicy open source information about who is involved in these things. Some of the names that have surfaced from this, there's some really weird stuff in here. Like, for instance, is the Chicago Blackhawks hockey team? This is real for 1.26 million.
At first blush, might be like, well, yeah, of course, just, check the boxes. But if
Just
you
log
are
the trade, bro.
Yeah, just log the trade. That's not how it works.
Now, this is very much a he said, she said story.
Riddled with drama.
Anchorage Digital is a platform for everything that an institution could need in order to interact in the digital asset ecosystem. If you are someone looking to buy assets, looking to hold assets, looking to stake, collateralize, trade derivatives, we provide the entire full suite, one-stop shop that any institutional investor might need in order to utilize digital assets. We have 1,000 clients on the platform and growing more every single day. And we are increasingly expanding the offering to support institutions looking to build businesses in the digital asset ecosystem. Folks that are looking to utilize the platform in order to integrate it into their bank, into their fintech, into their offering. That part of our platform is growing really nicely. And then additionally, we are getting big into the stablecoin business, looking at how to allow people to issue stablecoins, how to settle stablecoins.